Ladies and gentlemen, welcome to AO Conference. Woo! We need to get some more coffee here. We have 4 hours of the best and brightest minds from around the permaweb. And right now, there is no better nor brighter mind than the creator of AO and RReeve, Sam Williams. Sam, you want to come on up?
And slides would be great, please. Hey, everyone. All right, so with any luck, we'll have some slides soon. Okay, we're good. All right, so these events, I think, are a good opportunity for core permaweb builders to get together and discuss. Like, you'll find that actually most of us in the audience here are people that live and work on the permaweb every day. And so I wanted to give a kind of overview of where, from Forward Research's perspective, we are, and flexible and composable. Another thing that came with mainnet is what we're calling AO Core, which is essentially it's a primitive for the internet, fundamentally, that lets you express paths through the state space. So the sequence of messages that should be executed on top of a base message in order to get to a state. So if you have a smart contract, maybe it's a token, well, you execute each of the user's transactions on top, and you get to a specific, what we'd call a location in the state graph for that program. And what hash paths give us, what AO Core is sort of composed of, is basically taking that fundamental unit of what a blockchain is, this sequence of interactions on a deterministic program that get you to a specific state, and expressing it inside HTTP, using this new standard that was formalized last year called RFC 9421, or HTTP signed messages. And basically what it gives you is that every single message that moves around the system can be, if you will, like adding to its own blockchain. Basically every single state transformation, so an input that connects to an output, is tracked. And so when you get a message back from a Hyperbeam node, even if you're just accessing like the info page for the node, or something else like a piece of data stored on Arweave, you get back this little attestation that is signed, and it references, or it connects a reference to a particular spot in the state space with a particular output. And this is like the fundamental unit required in order to have verifiability and fraud proofs. And so on top of this, we also launched TEE support yesterday. So you can run your own node, and when you get back one of these hash paths and a state associated with it, some data, you can know with a very high degree of certainty that that is actually the piece of data that is found at that particular location. And one of the things I wanted to highlight here, that because it's a sort of relatively closed audience of core permaweb developers, is this concept that those hash paths can be merged together. So in this example, we have 4 parallel processes or computations in AO Core, and each one is leading to a message that is sent to another process. And when it does so, it carries with it the hash path that led to the creation of that message. And this happens recursively. So over time, what you end up with is a single unified, I skipped the text slide, sorry. A single unified hash path at the top that is a Merkle root of all of the computations that went into the creation of that message that you're seeing. And this is something that I think, I mean, frankly, when we were looking at this at Forward Research, you can intuit pretty quickly that that's very powerful. And my sense is that there's a bunch of things that we can do with that that are as yet very unexplored. It's open territory. So if you can, one example is that you get a message out the top of this, and it will, let's say that bank there is actually a token process, and that sends a message, or maybe it's a state channel, right? Someone is streaming a video, they're paying a gateway for it, a Hyperbeam node, for access to the content. And then that operator of that Hyperbeam node settles the payment into wrapped R. And then from wrapped R, they swap it into AO, let's say, something of this kind. So then when you take the output 10 years later from the AO process, you now have a Merkle tree that includes the ordering of all of the transactions that happened even down to that state channel right at the beginning. And this is all represented in a single 256-bit Merkle root. And we also left it open in AO Core, so you can implement other algorithms as the, someone is waving, I can't tell why. Okay, they say thumbs up now, who knows what that means. Yeah, we left it open so the algorithm that is used to add to the hash path is something you can swap out later as well. So for example, you could make a version of the hash path algorithm that will only include state transitions that have been signed by, today, a TEE. So when you get back the root at the end of the system 10 years later, then you know that all of the computation that happened in the subset of the network, which would be, if you play this out, I think you'll end up with like 95, 99% of all of the compute being expressed in these single values. Yeah, you know that all of that compute happened correctly up to the, would you say, security properties of the hash path algorithm that was used on it. You could also do the same with ZK proofs if you so desired. It's open to that. So if there are any builders that want to take that mantle and run with it, I think there's a bunch of really cool places it can go. But right now, it's just greenfield, like totally unexplored. OK, so another thing that AO Core gives us is the ability to merge together state representations. So you get a message output from one machine, you get it from another machine. If they agree, then you can merge together the signatures. And this is another fundamental primitive that's needed in order to have multiple attestations of correctness. And it shipped with AO mainnet 2 weeks ago. So yeah, you get a global unified Merkle tree of almost every computation. The interesting part here is almost. That sounds like a negative when you first encounter it. But actually you realize that like without creating communication overhead. So for example, in Ethereum, right, you get a state representation out the end of every block that is 100% of the network, right? But you only have one thread. And in order to achieve that representation, you've had to compute it on, I think it's between 12 and 60,000 nodes, depending on the time. What hash paths and AO Core gives us is you get almost all of the computation, but it happens naturally as messages move around the system. There is precisely zero additional overhead from the communication perspective. And from the compute perspective, you need to do one additional hash, and that's it, every time a message is passed. It's really powerful, I think. And a quick aside, yeah, this conference is about AO, but for everyone that's building on Arweave, which I guess is basically everyone here as well, yeah, the HTTP signature format is a new form of bundling, essentially, with a new type of data item that gives us a bunch of really cool properties that we didn't have before. So traditionally in Arweave, like when we first built it, it was supposed to be, well, it was built to be a ledger of history. And if you look at any sort of archives data structure, you see that you don't just refer to a piece of content by its raw identity of just the bytes themselves. That would be kind of crazy, in my view, because the bytes themselves don't really tell you very much. What you need to know is who said it, when they said it, and associated metadata. And so that was baked into the first transaction format of Arweave. And that associated metadata component was left open to the user to decide what is relevant to them. And fast forward 7 years, and that has become the backbone of the indexing systems that make a bunch of the applications on the permaweb run. But a constant complaint we've seen along the way, understandably, is, well, hey, those tags, as they're called, they're a fixed size, and they can only be binaries. And it's very difficult to get a recursive structure. In fact, I haven't seen anyone in practice create a recursive structure. So when we were looking at building Hyperbeam and AO Core, it became very obvious that this would be a good opportunity to widen the design space that's offered by the core data storage primitive. So yeah, now we get flexible keys and values. That means that everything in the map, the message, is a flexible component. There's no difference now between tags and like normal metadata. That's all just one thing. And the same with the data field. Those that have built with the system will know that there's only one piece of data that you attach to an Arweave transaction, which is kind of annoying sometimes. You want to add multiple pieces of data. Well, now you can. You can have as many documents as you want inside the same single message, all associated with just keys and values. It's like a classic dictionary map structure. You also get multi-signature uploads, of course, because, yeah, with HTTP SIG, we get that out of the box. And you get recursive messages. So now you can make, I guess in the old world, we would have thought of this as bundles that contain bundles. But they're not just referred to by like their index inside. You could have, in theory, and again, I don't think I ever saw anyone do this in practice because it was so janky. You could say, hey, I've got a bundle of data, and number 5 in the bundle is going to be this other piece of information that is necessary for this computation I'm running or this service I'm offering. Instead, now you can just, everything has a name. So if you want to, you can have a list of items inside the bundle, but you can also say the HTML document is this, and the API representation is like this. And you can serve that back on the same, it's the same message, essentially, contained in the same message. And something I didn't list here, but it's pretty cool, is when you recall these pieces of data on a Hyperbeam node, then you can actually traverse through the URL, or traverse through the data structure via the URL. So if we had a piece of data that's got like a body and also this sort of, let's say, a computer native representation, you could say like that piece of data, stroke API, stroke price, stroke BTC, or whatever it is. And so you can like recursively navigate through the bundle using like normal HTTP semantics. And also we have typed values now. This was another problem when people wanted to index the data. Sometimes you had like an integer, or you had a floating point number, or you wanted something to be a list. That was actually one we commonly saw. It led to people putting JSON inside tags, which is a nightmare. Well, you don't need to do that anymore. It's natively supported out the box. You can just have lists of values. Yeah, and also, all of this is expressed in like core HTTP semantics. So if you access a piece of data, in fact, if you go to a Hyperbeam node, you go to stroke any device and go to, say, an info endpoint, like the meta device, then what it will give you back is a HTTP structured document, which is a recursive bundle of multi-part form data, which is a little bit odd and specific, but TLDR is that every existing HTTP client library already knows how to parse that. And yeah, so we get library support in, these are 12 languages that are just listed on the httpsig.org website on day 1. And the standard itself was only ratified like a year ago. And you can already, out the box, use Scala if you want, or God knows why you would want to, but you can use Ruby to make these messages and send them to the network, and they can just be adopted. This is a huge, huge step up from what we had with Arweave transactions, where you had to have a specific library that someone had to make, and then they had to maintain. And so you got this common theme of like, okay, someone now wants to use the network in Java for some reason. Well, there's no library for that. So either they have to go and build it, and maybe they do build it, which would be great, but then they abandon it 6 months later. And so it's not up to date, and then someone comes and tries to use it 2 years down the line, and it's just not a smooth experience. We swapped that instead for everything that can use this sort of globally accepted common standard can now create Arweave data items and send them to the network. And something that hasn't progressed very far yet because the standard is so early, but I think in the future will be really, really cool, is that all of the different key management systems that emerge for HTTP signed messages will instantly be compatible with the network. And that means that as soon as someone makes a hardware wallet that manages these keys, and there's various reasons why you might want to do that in other, just on the web in general, we'll have support for it. And when people have key management systems for organizations, for enterprises, well, those are valid Arweave keys that can custody AO tokens of any kind. So I think it's pretty cool. And they look like this in practice. This is taken just from the Hyperbeam shell. But you can see here that this is a process state. So when you're executing a process in the background, what's happening is it's creating this recursive message structure where each of the different components is available as a navigable item. So you could go to that ID of that hash path stroke, for example, VFS, I think, is at the bottom here somewhere, and stroke dev stroke standard out. And then just in the browser, you can get to the standard output created by the WASM module. And you can see there it has rich types. Some things are lists, some things are integers. Yeah, and we can now index on top of all of that, and it uses unified, standardized formats. Even the typing is done using a sort of a neutral established standard called structured fields. So if you're trying to pass one of these documents down the line in some other program you're writing, well, if you can find a structured fields library, then there you go, you have support. You don't need anything special to use Arweave and the permaweb anymore. It's like the permaweb is integrating into the web as it currently exists in all of the standard frameworks and APIs. Okay, so AO Core itself is a system that exposes devices. I mentioned at the start that previously we had 3 different unit types, and each was a different code base. Well, the stack that you get when you check out the Hyperbeam repository today is 30 different devices, all of which we've built a sort of standardized tagging system for them to basically let you know as a user what level of development they're at. And so you can see here there's some things that are candidate mode. We define candidate as like, if you're a nerd like me, you'll know the request for comment system, the RFCs that are part of the internet standard, what would you say? The standard nomenclature of the internet, where they're not really actually a request for comment. They're like, this is probably the standard as will exist for decades. Yeah, that's what a candidate mode release means. You can reliably build on top of it and know that it won't change under your feet. Then we have this idea of a preview release, which is, okay, there are parts of this system, well, for a start, all of it is in place. It works, but there are parts of it that might need to be tweaked down the line. And then we also have early access releases. They're like, okay, it more or less works. You can use it for stuff, but don't be surprised if it changes under your feet. And the core idea here, and I would really sort of advocate that we adopt this widely in the community, is so that other developers and users downstream can know the robustness of the thing that they're building upon, right? Like the whole point of the crypto industry is to create protocols that offer users services rather than companies. And why do that? Well, because the protocols don't change. You as a user get actual reliable rights and guarantees when you use the protocol, rather than a company who can just turn around and change the game on you like 10 times a minute. And yeah, you're more or less beholden to them. And so by making a clear labeling system and having, if we were to adopt it all as a community, not just forward research, then it would be very easy for people to understand, okay, what rights and guarantees am I actually getting? So with an early access release, there's no real guarantee that it won't change. It most likely will in some form. And then in a preview release, it's like, okay, well, largely the structure's there, but I shouldn't depend on components of it too tightly because they might well change in the future. Whereas a candidate release is something like Bitcoin and it says, okay, here's the fundamental API, here's the way that you use it in practice, and maybe there are small tweaks down the line, although you don't need to adopt them, no one will force you to, but it's a robust, reliable service as is. And that's what really grants people rights. So 2 weeks ago, we shipped milestone 1, and it's about to ask who was a fan of the communications on mainnet, and there'll be 0 hands, including ours from Forward Research. This didn't pan out well. But to take another opportunity to explain the situation, we shipped Hyperbeam AO core, the core protocol now, we don't think will change. And those that are kind of close to the team will know that we've been like obsessively focused on tech for the last, really since summer. And the reason for that is because with Arweave, we saw there's a lot of pressure to get hype and engagement early for protocols. You see this like all over the crypto space. But the truth is that actually real adoption and use cases only come along when the tech is in place. And there's a real danger when you are building a protocol that actually people come to rely on the wrong version. So I think the story of Ethereum is actually encapsulated directly in this, which is that they had a great proof of concept. That was like our legacy net, testnet v1. But people started to adopt it at such a rapid pace that essentially that negotiation with the users and the developers around like what changes are admissible becomes harder and harder because it has a specific spot in the trade-off space. And the real like disaster from the at an Ethereum conference. So sorry guys, to be clear, Ethereum did some really amazing things. But in terms of the adoption of Ethereum over time, the catastrophic error was global shared state. And applications came to depend on this. This was just the way that you built Ethereum programs. And so in 2017, 2018, the scaling roadmap for Ethereum was to build sharding, which would have killed global shared state, as was like, obvious. I don't think I need to explain to you guys why that won't work. But they couldn't push it through because there were already users that had become not just accustomed to and acclimatized to, but they also depended on the software to run in that particular way. And so when it came time to get rid of global shared state, they couldn't really do so, and it led to this sort of 8-year quagmire of not really achieving the scalability that they wanted. So yeah, we've been really obsessively focused on getting the tech right, getting those fundamental units in place, and that's AO core at the base of it, and then an implementation with Hyperbeam, such that in the future we can build on top of it, and it's a modular structure, so each of these components can be swapped out at will at any time in the future without disturbing the other components of the system, and now we have a really solid base from which to work, which saved, in the case of Arweave, we had similar situation. We shipped V1, which was quite scalable, but like it wasn't going to scale infinitely, or like, to be precise, past the maximum the users wanted to use, basically. Like 2 to the power 256 bytes is what we ended up with Arweave 2.0. But before that, we had a lot of pressure from the community and from investors and the likes to go like push adoption and get people hyped about it. And we did so. But the truth is that they all flaked. Because when you went to use the software, it didn't do what you needed it to do. And so instead, we focused on getting the technology right. And now we're in a really great spot for community adoption and development. So Milestone 1, we call this. This is basically AO core is cemented in place, and also all of the units that were needed in order to perform payments. Just payments to start with. And that's about like, 8 different devices on top. And you can now spin up a Hyperbeam node, you have been able to for a couple of weeks, where you can set up a payment relay to existing AO infrastructure. So you spin up the other nodes, and then you can charge people for access. And the reason this is so important, and the first thing we focused on, is because anyone that's used AO legacy net or testnet knows that, wow, like sometimes it gets slow. And the answer for that is that, the reason for that is that when you have an open system where anyone can compute any amount of, or ask for any amount of computation they like, inevitably it leads to clogging of, there's only so much infrastructure being provided, and it's being provided for free. So you can't scale, you can't scale the infrastructure to deal with user demand because user demand is uncapped. There is absolutely zero cost to the user to generate requests. And so we have payments in place, and so, okay, now you can go to, I think it's like relay dot, I forget what the domain name was. Well, anyway, if you open up AOS and you say --relay, it'll take you there, which is kind of like a fast lane for existing infrastructure. But yesterday, we shipped, I think, a really, really exciting part of this stack, which is basically the ability for people to run Hyper-Beam native computation, as well as those payment systems, on top of AO Core. And what this means is, in practice, you can go open up AOS, say --mainnet, and it'll put your scheduler for your computation into a Hyper-Beam node. It runs natively inside the system. And then it'll do payments or whatever else you'd like it to do from the other devices, and also then curry the compute that you ask for to a LegacyNet compatible executor. It's actually just like a mini coup embedded inside a Hyper-Beam environment. And you can run all of that inside a TEE. So after payments, where we need to go next is making it so that people can push messages for one another around the system. Like right now, or on LegacyNet at least, when you started a process, you would set a default authority. And some people played with this in the community, made it so that they could also push messages for their users on those processes. But it's a sort of ring of trust, if you will. And what we have in place now in the sort of preview mode is, well, you can start up a node inside a TEE, which gives you very high levels of trust. Not perfect, not by any means, would you say? On its own, a single TEE attestation is good for some value, but you really want like multiple TEEs in order to get very, very strong correctness. But you can now start a Hyper-Beam node inside a TEE environment, join the green zone in preview mode, and essentially perform computation and have the messages that come out be reliable to some reasonably high degree, and then push those messages around the system. Now, it's going to take some time for that to get from preview to candidate release, but now people are already playing with it, and they're actually contributing to the Hyper-Beam repo, which is really cool to see. And so this is like the full view of what exists right now, and obviously the red stuff is where we want to go down the line. There's a bunch of stuff you can already do with this in practice that I think is super cool. So when you have an AO process on a Hyper-Beam node, then you can access parts of its state, and you can actually also export from the WASM environment to the external host. Again, in preview mode right now, there's probably going to be issues, but you can like try it out, test it, and within a relatively short period, I think it'll be stable, candidate mode. You can make it so that you can like render web pages. So here is a web page, just says hello world, but it was dynamically generated by that process underneath. It's like a web page served directly from a smart contract. And even the last mile from the smart contract to the user's browser is protected by that hash path mechanism. So you're essentially saying, hey, give me the state at this position in the state space, and it will give you back a renderable web page. But it doesn't just have to be web pages. You can have full APIs expressed this way. So you can now, instead of having to query and basically like simulate what would happen if you sent a message to a process, you can just embed, or rather export from your WASM environment, essentially bits of state, to the host Hyper-Beam environment, into that like AO core state message for the process at any point in time. And then you can just say your process ID on any Hyper-Beam node stroke now stroke price, and it will give you back that bit of state inside the system. And then you can even do like more complex things, like say now stroke balances stroke user. And where this goes in practice is that no more dry runs. Yeah, exactly. All right. Like when you want to perform a computation on AO LegacyNet right now, what actually happens in the background is that and I won't mention the name of this project, but there's a widely used project in the ecosystem that you load the homepage and it performs 80 dry runs, 80 simulations of interactions with those WASM containers. And for some context, it takes 1/3 of a second to invoke that WASM container, run the computation, and get the output. You're doing that 80 times in order for the user to load just one page. That's an unbelievable amount of compute. Instead of that, we have these extremely cacheable values where you can just export every time the state changes a patch on the state of the process, and then the user can get to it just by the URL bar, or you can, basically dynamically do it in JavaScript, and boom, you've turned that 80 requests into like 80 requests for little values that are just like using a web server. It's going to be like massively, massively more performant. So that's yeah, that's exciting, and you can play around with that today. It's a little bit janky interface, but it's there, and soon I think it'll be widely deployed. But it actually goes kind of deeper than that. So here are some example URLs that you can use with AO Core. If you're used to developing and familiar with Bash scripts, I think the way to understand the AO Core URL bar, or the path that you can go to in on a Hyperbeam node, is basically that each is a mini blockchain, and you can specify the interactions you want to have happen in sequence. And it can be like immensely deep. So for example, we have a URL here where the top one, you're going to a specific hash path. And that doesn't need to be a process. It can actually just be like a serverless function with no scheduler. It's just a specific existing point in the state space. And you're saying compute and get the results and run this WASM function factorial with these parameters. And you can also specify that the parameters are a list. And you can do that all in the URL bar, which is kind of like interesting curiosity, but it turns out actually in practice, this could lead to really, really cool effects. So the second URL we have, we take the process and we get the schedule, and we say the body, or rather we're posting to a process's schedule, and we set the body to be a different path. And so essentially this sub-resolution system allows you to kind of create another little blockchain and then merge the two results at the end. So this says, go to this process ID, compute it at state 7, slot 7, get the results, get the outbox, get the first message from it. Now you've got that message, and you're essentially, that's a messaging unit in AO LegacyNet, like in a single URL. And anyone can construct them of any form. It's like the URL bar itself becomes general purpose compute. Yeah, I think there's, and this bottom one, so for example, you want an oracle. You want to get the price from Binance of Bitcoin. Well, you just use the relay device, and then it will give you back a HTTP signed message that you can validate is running inside a TEE, so it hasn't been corrupted. And that's one URL bar, or like that's one GET request to perform what would otherwise be like a massive piece of engineering. Where we see this going down the line is that, like, in the same way that building a computer yourself is not the process of like putting transistors on a chip. You just pick up parts and they stick together. It's like kind of Lego in a sense. Well, this is Lego for blockchain applications. It's a big box of different tools, and you can just construct the service that you actually need by like reusing them. So building a new blockchain or a new service that has specific compute requirements, security requirements, should really just be a case of configuration, not a case of building and development, which should cut down the cost of innovation massively, which is something we're excited about. So the next thing that we're focused on is getting it so that, I think these slides are unfortunately swapped. That is unhelpful. Well, getting it so that the scheduler and the delegated compute system, that's the one that lets you call out to the embedded CU inside Hyperbeam, and the Genesis WASM device that sort of like orchestrates that process, is all in stable release. And when we have this, we'll be able to access legacy net processes on mainnet. So if you take nothing else from this, I think we could use it to clear up the confusion about mainnet, legacy net. The reality is that all of your data, if you have a legacy net process, is on Arweave. So it doesn't really live in legacy net per se. It's that you're using legacy net infrastructure to execute that process. And where we want to go with milestone 3 is making it so that those processes are then fully compatible with Hyperbeam nodes. So you can start pulling them down and running them inside Hyperbeam environment and making use of, for example, that no more dry runs feature and exporting state and the likes without updating your smart contract code necessarily actually at all. You can just continue to run them. Because the data is shared on Arweave, like there's a neutral place where it's all stored, which doesn't really exist in mainnet or legacy net. It's like, well, actually in this diagram it's explained pretty well. It's right at the base layer, underneath everything. So when you have this, then you'll be able to smoothly transition in a live fashion with no downtime between legacy net infrastructure and mainnet infrastructure. And at that point, people can start using payments and start running their own computation inside TEEs and start pushing those messages around, and you end up with a fully decentralized supercomputer at the end of it. After that, we want the green zone to reach stability. And this allows you to do not just everything I just described, but also private computation, provably private computation even, which could be useful for many things in the ecosystem. Like, I know we have the Randau team with us today. Well, they can make it so that the generation of entropy that goes into the Randau process can also be hidden inside a verifiably secure container where no one can see the state transformations. You can also, for example, have a piece of data stored on Arweave that you then pay to access, and only when you have paid do you get to see the content, which is something we've had probably 100 requests for over the years. Now building those services will be very, very easy. After that, where we want to go is this system called AOT. It's ahead of time compiled WASM code. So the new Hyperbeam native computation system, which we already have in place but not running in AOT mode, and like most of the existing processes, actually all of the existing processes and most of the new processes will use the embedded CU. But yeah, it allows basically to, when you see a WASM container, you can then compile that to native assembly code on whatever platform you have and run it at like 90% approximately of native speeds. So if we want to build a supercomputer, this is how we make it so that it's running at like full pelt. Every single CPU you throw at it gets you 1 CPU worth of computation out the side, at the end. Whereas right now, maybe you get like, I don't know, a third or a half, something like this. So this would be a big efficiency improvement. And yeah, we're also not the only people building. We're just having a conversation this morning with the APUS team about the GPU devices they want to build on top of this. They already have an implementation of WASI-NN, the WebAssembly Standard Interface Neural Network standard, which allows you to call out and do basically, well, most obvious use case for it is large language model style computation on a GPU from inside a WASM environment, and then, as a consequence, inside a Hyperbeam environment, and even inside a TEE, giving you correctness guarantees about the LLM output. And there's also another web GPU project ongoing with a sort of different version of the WASM environment. But where next after that? Well, now our attention is starting to turn back to growing the usage of the system. Now we have the tech in place, we can really tell people about it and grow the environment that already exists inside AO. And I think a huge thing that people missed with the mainnet launch, or didn't really receive the attention that I think it's probably worth, is Pi. It's like, it's big. It's very, very, very big. I think this will be huge for the ecosystem long term. Essentially, what it means is that as it stands today, and I haven't checked the numbers in the last week or so, but from the pre-delegations that people have made, 40% of the value, approximately 30 to 40% of the value from AO minted tokens will all flow to the ecosystem, to ecosystem projects without there being a centralized party in the middle, like a grants committee that is sitting there deciding where the money goes. No, instead it's just following the delegations that real users of the permaweb are making with their Arweave tokens or with their bridged assets. And so if you work that out on a per day basis, I haven't done so with the latest prices of AO, but last time I calculated, it was something like, it easily gets into the hundreds of thousands of dollars per day invested into the ecosystem. So if you're building an ecosystem project, this is a way that you can get access to capital in a fair and transparent manner where, if you will, your audience that you're attempting to convince is just the wide public, everyone using the permaweb. And it's on completely equal terms. And a secondary effect of this, slide order again, damn it. A secondary effect of this is that you start to build an extremely wide ecosystem of people that are staked into the success of your project, like long-term, right from the start, even before those tokens are liquid. And you can do this without actually having to reach them directly. So, of the people that have delegated, there's probably, I would guess, 4,000 plus all of the Arweave token holders, or not all, actually, rather most of the Arweave token holders, which is into like 200,000 approximately, that will become stakeholders in your project just by proxy. And that means when they see your posts on X and you're trying to engage your community, well, there's a set of people that are out there that are willing to listen from day one, which for a new project is a huge, huge deal. You get a very, very wide base of supporters virtually instantly with this system. And even cooler, they all get in on equal terms. There's no favoritism, it's just open and transparent, and it provides you funding at the same time. Did I mention that I think this will be big? Thank you. I think this is going to be very, very exciting for the whole ecosystem. And yes, to take it back to this slide that was out of order, there are already actually 6 projects, one of which is not on here, which is a shame because they're the people that took the leap early and were basically like jumping into the deep end when this was just an idea, and that's Apis Network, who already had a mint live since the end of December. And at one point they had $7 million essentially deposited into their minting process, fair launch minting process. And a really interesting byproduct here that is not understood, I think, at all yet at this point, is that the yield that is distributed as funding is not the native yield. It's actually the yield in AO terms. And what that means in practice is that okay, now we get into the weeds of the mechanism design, but the yield that you get is the yield over base of the native, which TLDR today sits at approximately 2.5 times what it is for the native assets. So actually, the last time I calculated it, the yield that these projects would get on those deposited funds in their fair launch process is like 40% per year. Now, it probably won't stay that way because markets are efficient. Markets are eventually efficient. But yeah, during the time where that value is smoothly moving down towards some efficient level, probably somewhere over the native asset yields, yeah, the yield that you get from those deposited assets is extremely high. So that just magnifies the amount of capital that is going into the ecosystem, helping people build stuff. All right, so there we are. That's where we are, and that's where we're going. Thank you, everyone, for listening. And yeah, I'm excited for all the talks today.
Engaging online worlds, the one, the only, Mr. Matt Mason of Base Jump.
Thank you. Can you all hear me? Oh, what's going on?
Mirror that.
All right, that's happening?
Yeah, you got to mirror.
Oh, wait, okay.
Or extend.
Sorry, technical difficulties. Where do I do that?
You want to go into where the mirroring is and the display settings.
Oh, yeah, okay.
Over here on the menu. Like what menu? Oh, this one.
Sorry about this, ladies and gentlemen. Like Sam, I'm also British, but I'm not as smart and I'm not as technical, clearly. I do swear more as well, so I apologize in advance for that. But we're about to get kicked off. My name is Matt Mason. I'm the CEO and co-founder of BaseJump. Thank you. So we're building a new platform that makes it very easy to create, share, and connect games, game assets, and worlds. And one thing I want to talk about today is why we're doing that now, and also why are we doing that on AO and Arweave. So the reason we're doing this now, the reason we think this makes sense now is because games are fundamentally changing. Gaming's never been more popular. About half the world use game assets, mostly in games, but also in streaming platforms and in social networks. People are getting more and more attached to their game assets. About 40% of Gen Z players update them monthly, and more Gen Zs would rather work in gaming than be a doctor or a lawyer or a professional athlete. So that's all amazing. But gaming's still really, really closed. It's very fragmented, and it's never been easier to make a game, but it's still very, very difficult to make a game. Because it's easier, games are becoming something else. So there used to be applications, but actually if you look at where gaming is at now, games are becoming content. If you look at Roblox, Roblox is now the size of Nintendo, Xbox, and PlayStation combined. And the only thing happening on Roblox is kids making games on Roblox themselves. Same thing on Minecraft. If you look at Fortnite, 19 of the top 20 developers are single devs pulling all-nighters and making maps that people play, and then they go away the next day. So gaming's getting more ephemeral, and this idea of owning your assets is becoming more important to people. The big tension is that you can't move these assets from one platform to another. And we got a glimpse at BaseJump of what it might be like when the world is like that, when we created an NFT community called Broadside a couple of years ago. This was an NFT project. It was very sort of story-driven. It was about this sort of fictitious future world that we made up. And we had this whole plan for Broadside, but the Broadside community decided to go in a completely different direction. They decided they were going to become the most engaged community in all of the open metaverse, and they were going to take their assets across all kinds of games and platforms and worlds and do all kinds of things with them that we didn't imagine. So, for example, they built this place called the Broadside Rave Bunker. This is the most popular nightclub in the metaverse. It's kind of like what CBGB was to punk or Studio 54 was to disco. The Broadside community holds raves in here every single week. They've done that for the last 2 years. This event is streaming in there right now. They're watching this right now in the Rave Bunker. You can get in there yourself if you go to Broadside Twitter. We've had all kinds of people like The Prodigy and DJs like Roger Sanchez. People have come and performed in the Rave Bunker just because it was a weird and fun thing happening on the internet and they wanted to know more about it. And the Broadside community just sort of kept taking this further. So we did this Metaverse World Tour. We did a bunch of live events that were also in the Metaverse. The community just keeps sideloading and doing weird things with their assets. So they're bringing them into Roblox games, into GTA, all kinds of crazy stuff. And the Broadside community, because they had the rights to their game assets and because they could move them all kinds of places, they did all kinds of stuff with them. And after the end of the first year of Broadside, the average revenue per user that we were making from Broadside was about $98 a user. So to put that in context, the ARPU on Roblox is about $15 and the ARPU on Fortnite is about $7. And NFT communities are different. Oh, that number doesn't include the mint price of $75 that they initially paid for the 7,000 Broadside characters. This is revenue earned from an additional sort of 45,000 NFTs and merch and other things that we did. But what this really showed us was that interoperable game assets are really fun and they're really valuable if you give people rights to do all kinds of things with them. they'll do things with them, and then that will create more value for you as a company. So we decided this is a really, really cool group of people, and we want to build a platform that kind of serves them. So myself and my co-founders, we've been working scaling some of the biggest platforms in blockchain, consumer tech, and gaming for a really long time. And we realized that between the three of us, we were probably actually a really good team to try and do this. So like, let's build a new platform that really addresses this reality of a world where games are content and assets are interoperable. And so that's the big idea behind BaseJump. This is the sort of home screen of BaseJump. It looks like a loadout screen for a game, but it's a loadout screen for the internet built on game engines. It's got a permissionless gaming substrate under the hood called Action, which lets you create a game or a game asset with a simple text prompt, and then deploy to any of the big game engines, social apps, anywhere that accepts game assets instantly. So this is all live right now. If you go to BaseJump XYZ, this is very much the kind of, we sort of think of this like the splash page for what we're building. We're launching our first game in the spring. It's called Battle Mode. It's going to launch on browsers and in Discord. It kind of plays like Super Smash Brothers or Street Fighter 2, except you can load in with different armor or weapons or objects. So it's like Street Fighter 2 meets rock, paper, scissors is how we're thinking about it. The reason that we're building a game is because all of the metaverses that have scaled, Roblox, Fortnite, GTA, Minecraft, have really, really, really amazing core game loops. All of the metaverse platforms in the last cycle that haven't scaled don't really have core game loops. They're mostly kind of tool sets. You go in there, you kind of walk around, there's no one there, you leave and you never come back. Core game loops are really important. We've built game studios and games before. This is the first thing we're working on because this is the most important thing for users. So the way that this will work, here's a screenshot from the battle mode game. So you can take in your avatar, load it up with a weapon, battle somebody else, do this straight from Discord or in your browser. The level that you're seeing here and all of the levels here are powered by Action. They're all procedurally generated. And once we've got the game out, the next phase will be putting the Action app into the hands of users so that you can procedurally generate these levels yourself, and you can start making your own levels for this first core game loop that we're building. These are some early tests that we've done using the Action platform. And like straight away, we just playing with it ourselves, we started making stupid things like, we wanted to do a level that was about Pepe, so it sort of came out like a lily pond. Or this one down here is kind of a sort of green screen terminal. But very quickly, we started to realize that if it's really easy to make a game, if it's as easy to make a game as it is to make a post on Instagram, then games are going to become memes. Like this is another thing that we made where it really felt like this is a playable level that is just sort of a meme. Some of these things you might make and share with your friends, and then they'll disappear, or maybe it's a really good game and you want to monetize it for a really long time, so you store it and you publish it on Arweave. And that's where the stack comes in. Like none of this was possible before AO and Arweave. Action is this layer of scalable gaming infrastructure that we're building. AO makes it possible to instantly create these levels, and Arweave lets you store them permanently. So, once we got in touch with Tate, the team at Community Labs, and we met Sam and everybody at Ford Research, we kind of realized that everything else was legacy tech. Like once you really understand what's possible here, it's just kind of mind-blowing. So we're so excited to be building here with so many of you in the ecosystem. So like getting into what Action does a little bit more, it will have a token. It does a lot of the things that a token will do, like governance. It has this impact thing, which I'll get to in a moment. It's also a way to pay for compute on the network. But half of what Action does is really about specific stuff to game assets. These could be avatars or weapons, items, or even entire games. We call these objects on Action hyperobjects. And one of the important things that the Action Network does is it actually just registers these objects and kind of explains what they are and what they do and what they might do in different worlds. And because it's all on chain, it means these objects can also be network aware and context aware, which lets you do some really crazy things. So here's an example of hyperobjects. If the internet's going to run on game engines, we think of hyperobjects as the connective tissue that connects everything in that internet, much like hypertext connects the internet that we use today. So here's an example of a hyperobject. This is a broadside character called Stinger. You can see him here. He's got a rocket launcher and he's holding some ramen. All of these things are hyperobjects. If you take Stinger and you load him into this platform, Chorus, which is a platform running on Base and Polygon, it's an AI music game creation platform. The chain doesn't matter. You can bring Stinger in there and you can start making AI music with him. And because Chorus knows that he's a broadside avatar, it's going to load up some broadside-specific beats and acapellas and game loops for you. Here's Stinger playing in Nifty Island. Here he is in an app called Alias, which is for streaming and VTubing. So you can start to do some really crazy stuff. And this rocket launcher that Stinger is holding, if you take that rocket launcher into Nifty Island, it knows it's in Nifty Island. And Nifty Island, you play Capture the Flag, King of the Hill, these type of games. That rocket launcher will fire bullets in Nifty Island because that's what it was designed to do. If you take that same rocket launcher into the broadside rave bunker, it will fire glow sticks because it knows it's in the rave bunker. And I think that's what, with gaming, gamers don't like blockchain because all they've been shown is the casino. We need to start showing people the magic of blockchain. Why does this make gaming more fun? And we think hyperobjects is a really interesting way to do that. So hyperobjects make things more fun, but they also can help you explain some of the more sort of complex ideas behind crypto. We're releasing a collection of new action figure hyperobjects that will also run as nodes that will operate to secure the network. We've got 7,000 OG broadside action figures. They will be the first ones that run as nodes, securing the network. We've got 100,000 others ready to go. I think Ethereum's got about 6,000 validators on it right now. So if you put a really fun gaming UI on front of things like nodes or some of the more complex aspects of DeFi, you're going to help more people understand why DeFi is important or why something like a node is important. If you show a gamer a platform where the platform isn't front and center, but their character is front and center, their assets are front and center, their data, and they're intuitively understanding that they own all that stuff and they can take it with them wherever they go, I can't think of a better way to explain decentralization to someone without having to say a single word. I think this is how all of blockchain is going to scale. I really believe that gaming is the magic bullet, and we're really trying to take a crack at that with what we're doing here. And there's some other things we're thinking about. So we think this is also a really interesting way to solve complex problems that currently governments and corporations are failing at. So we wanted to sort of bring in this whole element of impact into what we're doing with Action. We partnered with the Rainforest Foundation US, and for our first launch of the Action token on the PermaWeb Index, we're aiming to protect a specific 4 million acre area of rainforest in Peru, where every single Action token, whether it's a hyperobject or simply a token, will be connected to a specific area of rainforest. And this is the map of the actual area. This is what you're going to see in the UI on Broadside, is tokens and avatars slowly protecting an area and really gamifying this. So this is something that we want to scale to all kinds of games and all kinds of communities, because this is a game, right? This is Capture the Flag. This is King of the Hill. This is defending territory. We've seen in the non-profit world, like if you adopt a goat or something, you're connected to that goat and you'll get emails about it. And if the goat's not feeling well, maybe you'll send another $5. This stuff works in non-profit. Why aren't we using this in gaming to protect real-world areas that need protecting? So we're really hoping to scale this. This is a 4 million acre area that we're starting with. There's 3.3 billion other acres of rainforest to protect, but there's ocean garbage patch to clean up, and there's dust bowls to rewild. We want to use Action to turn saving the world into the world's greatest game, because it's something that we think you can only do using blockchain, and AO is really, really perfect for doing this. So that's what we're doing. We're really excited to be launching as part of the PermaWeb Index with the Action token on March 14th. Stake your AO, you can earn Action. We like this because it gets tokens into the hands of many, many people as soon as possible. And yeah, look, we're just so excited to be building with all of you in this ecosystem. I love everyone I've met across AO and Arweave, and everybody who's working here. Everyone I feel like out here is doing really, really interesting things with blockchain to really make the world better, and that's what it's all about as far as we're concerned. So do get in touch if this sounds interesting. Thank you very much.
Thank you so much, Matt. Appreciate you. Our next guest is from Apis. Apis is one of the most interesting projects on AO and the permaweb, and to explain it further, we have Mr. Connor Thacker, head of community at Apis. Connor.
Just speak close to the mic.
Take out.
You can take it off.
Nice one. All right, guys. I'm Connor. I'm head of community at Apis Network. I know some of you know me, some of you don't. I will skip past this. Firstly, who are we and what are Apis Network? You may have seen it in the first slide that what we are doing is enabling verifiable decentralized AI through deterministic computations. And the second words that I didn't leave on the first slide are that it's on AO, and that's really important for us. The second thing we're doing is that we're running competition pools. So we're incentivizing people to build high-quality AI models, right? We don't want a bunch of rubbish being put out there, so we're financially incentivizing people to produce quality AI models, and also for people to be able to gain access to those models. So if you don't know what you're building or how to build an AI model, which is most people, we're enabling you to do that. Just set a fee, developers can push the models forward, and the best one ends up being yours. You'll have ownership. We are, as Sam mentioned, also the first project on AO to go ahead and run the community launch token as an AO token, and we did get up to, it was $7 million in assets bridged towards us within the first 7 days. So we were really happy with that. Okay, now AO mainnet and Apis Network. You've heard a lot about what's been going on with AO from Sam over the last couple of days, and now sort of how that's going to reflect with what we're doing. So the first thing, and it is important to us, but perhaps not the most important, is that what we're doing for our consensus on our verifiability is we're leveraging determinism. And our own consensus on this is we're using fast provable inference faults. And this is going to align perfectly with the TEs that are going live on AO's nodes. Perhaps the most important thing is going to be this. So we're building a WASI-NN device for native GPU support on Hyperbeam for AI. So at the moment, I believe we are, well, basically, we are going to be one of the first devices going live for this. I know we talk a lot about building something for AI on AO, but I can say we will be pushing the code live for this on Pi Day on March 14th. So for anyone who wants to check it out, there will actually be a version on March 14th for you guys to look at. And talking about Pi Day, as the other guys have mentioned, we're really excited to be part of the Perm Web Index. So also going live on March 14th, and that's going to, well, it will root a huge amount of value to our community, and also for the entire AO ecosystem, right? So we're really excited for that. The next thing I have coming up, and I hope it's going to work because we have some voiceovers over the videos, is we want to actually show people what we've been building. So we're going to have a couple of little demonstrations. The first one's just going to show the difference between CPU on AO and GPU when we're looking at AI inference and just how big difference the speed is. And then we're going to have a look at our deterministic GPU, our Hyperbeam extension. So we're going to have a look at an example of both of those, hopefully. Maybe working. Yeah, so one thing to note on these videos is that the model is going to remain the same. The quantizations remain the same. The only thing that's different is we're going to look at an Intel CPU and an NVIDIA GPU.
Let's explore how GPU acceleration transforms AI inference speeds compared to traditional CPU processing. CPU inference runs on AO Loader, the foundation of AO's legacy network. GPU inference utilizes IWASM.
We might need that backup.
WASM runtime powering AO mainnet. They both use the same prompt.
Sort of semi-expected technical difficulties. We're not going to have sound on this one, though.
Which requires AI to refine copy. GPU completion time, 1.
I can't use that. We don't have the extension. Yeah, it's not loading at all.
179S. A few minutes later. CPU completion time, 393s. While the CPU took 393 seconds, the GPU smashed it in 1.179 seconds. That's 350x faster on pure compute power. Plus, GPU's dedicated memory handles heavy loads smoothly, while CPUs struggle with bottlenecks. In the AO ecosystem, deterministic is non-negotiable, but GPUs face unique challenges here. APUS ensures determinism by, first, using integer quantized models to simplify precision control. Second, strategically disabling non-deterministic GPU optimizations. Let's see the AI inference comparison between NVIDIA L20 and 4090. Both of the prompts are the same, which asking AI to continue writing after once upon a time. NVIDIA L20 output, 445 tokens end with a new life for themselves. NVIDIA 4090 output, also 445 tokens end with a new life for themselves. Bit-for-bit identical outputs, and even after multiple runs, the result is still remain the same. Deterministic. While sacrificing 15 to 50% potential speed gains, APUS's GPU integration maintains AO's determinism standards and enables verifiable AI computation.
Okay, so I think hopefully people managed to get the first part of that video. What we did manage to demonstrate was that the GPU actually managed to process the inference 350 times faster than the CPU. And that was just with a really small prompt. If we start to increase the number of tokens we're putting in there, that difference is only going to grow. So for anyone who has been using AO Legacy running AI, and I know some of you have been building on it, some of you have used our competition pools, which it is been painfully slow. So having GPU on AO is going to be something that is increasingly important, especially as I know a lot of us do want to be using AI. And the second video displays that we now have the determinism model running. It is running there on the same WASM runtime that is used on Hyper-Beam. And we have it running across two different NVIDIA GPU cards there. So at this point, people may be asking, why do we need deterministic, right? Why do we need to be getting the same results? And this can be used in anything across the people are developing, whether you're looking at AgentFi, whether you're looking at trading bots, anything you're looking for, is going to possibly require determinism. But perhaps most importantly is we're trying to build on-chain verifiable AI, and one of the easiest and best ways for us to prove that we can have on-chain and verifiable is if we keep those deterministic standards, which are sort of the core of AO's compute as well. So hopefully that demos something, and we will have something live for you to actually test, like I said. We'll hopefully not play them again. Coming back to sort of what we've done otherwise, it is sort of AO and Forward Research have been pushing the fair launch season and the perma-brawl. Big thanks to Drew for that one. Why was the fair launch important for us? You know, the AO ecosystem sort of, we want to follow the same ethos, right? AO was probably one of the first purely fair launch tokens that Web3 has seen for a really long time. And it's really nice going back to that because early days of Bitcoin, that was the idea, right? So we thought, well, we'll go with that and we'll continue that. And hopefully this also sets an example for others in the space. And I know that we're not alone, right? There's a lot of us doing this. And I feel that it's really nice to see a Web3 ecosystem sort of following in that suit. So we had our TGE, that was in December last year. We had 7 million assets bridged within the first 7 days. And then on March 14th this year, we will be joining the Pi Index too. So as much as that's bringing exposure for us, we're also really happy that's going to bring exposure to the broader AO ecosystem. And then just regarding the perma-brawl, Forward Research have been really generous. They are offering 3,142 Pi tokens, AO tokens, across 4 different companies. So that's ARIO, that is Bazaar, that is Basejump, and that is us. So just come out, check it out. It is the QR code on the right. They're really easy competitions. You have a chance to win some of those. It's quite a huge amount of money and dollar value. So do just, it's a little bit of fun as well. You're interacting with a digital version of Sam Williams. And then, sorry, Sam. And then you get to post that on Twitter as well. So not only do you get to interact with him, you get to share his response. We take no responsibility for his replies on that one. But yeah, please do check that out. On the left, you'll find the link to our website. Our mint is live, delegations are open. And yeah, really happy to be here. And yeah, thank you guys.
Thank you so much, Connor. For our next speaker, there are certain people in this world who you only need to know their name and you already know everything. I'm talking Elvis, I'm talking Bono, I'm talking Phil.
Hey, everyone. Okay. Display settings. Okay. All right. How's everyone doing? I see a lot of familiar faces. That makes me feel really good. I feel like I know everyone in the ecosystem. Some of this might be repeat for you. You might already be familiar, but glad to talk about RIO, Permanent Cloud Network, and really what it does and what it even means. So thank you again, Forward Research, for having me here, and let's get into it. You guys already know who I am. I've been in the Arweave ecosystem since 2018. I quit my job and founded PDS and started with R Drive in 2020. So it's been a heck of a ride. Last week we launched the RIO Network mainnet. So today I really wanted to focus on that and talk to you guys about its benefits and maybe how you could take advantage of it if you already are not. So while Arweave provides this foundation for permanent storage, RIO really builds the infrastructure and services to create the world's, what we like to say, the world's first fully permanent and equitable cloud network. It's an open source cloud, and it really provides storage, hosting, data access, really without any subscriptions or centralized control. And we like to think we're trying to really set this new standard for cloud infrastructure in general. And that's based off of a few pillars, we call them, right? So it's a network that's obviously resilient, right? No single point of failure, incentives that can keep the network self-sustaining, so no single team could go away and falter the network, and it's censorship resistant, right? No single team, person, node, et cetera, can take anyone's voice, can remove their content, and so on. All of the data stored on this network is stored on Arweave, right? So it's timestamped, tamper-proof, and it's there indefinitely. Very unique property that you just don't get with other Web3 systems or Web2 for that matter. One of the amazing things I think about this cloud is it's interoperable, right? Meaning it can integrate with other chains. You can bring different kinds of wallets to it. You don't just need an Arweave wallet. It supports different kinds of signature types. So that's really useful for bringing in people in other ecosystems. You can pay in different kinds of currencies. It's not locked to one specific token. And it's got this very familiar tooling setup that you might be familiar with if you're in Web 2, because it uses languages like JavaScript, TypeScript, Lua, et cetera. There's no special language you need to learn to build on it. It's sovereign by default, right? Users own their data. The apps deployed are user rights preserving. Everything is cryptographically signed, so it really provides this strong digital ownership. And we've designed the whole system to be on premises, right? It's not built to just be run as a SaaS. It's built to run at any kind of scale, whether it's a tiny, Raspberry Pi or, really beefy servers. And finally, it's transparent, right? And this is something you don't typically get with the normal clouds, right? Everything is open source. There's a clear record of data provenance for any action that happens because it's all stored on a public ledger, which is Arweave. So our vision is really based in these principles, and you'll see this be applied through all the technology that we're creating. As I mentioned, both types of clouds have all the tools you really need to build modern apps that scale, right? And whether it's doing things to store data, index it, retrieve it, or just a generalized compute platform where you need to create anything you want, really both clouds offer that. Sure, the traditional cloud does have things like SLAs and strong customer support, and it's widespread. It's adopted everywhere, right? Every business has some connectivity to some cloud somewhere. But really the advantages of the permanent cloud really can't be denied, whether it's the payment models, the censorship resistance, the immutability, provenance. There's a lot of really unique properties that you get beyond just storing data for a long time. Let's maybe drill into some of the specific services that the RIO network provides, because it does a lot, right? Gateways aren't just accessing data. They do uploading, right? Whether that's layer 1 Arweave transactions or layer 2 data items or bundles. The gateway comes with a bundler that can do that, right? It could also has very intelligent chunk broadcasting. As you might know, data on Arweave is all broken down into transaction headers and chunks. So the gateway comes with a specific broadcasting feature if you do need to, re-upload or broadcast chunks out to the broader Arweave network. Of course, gateways, I think they're first and foremost used to access Arweave data, and it does that through a contiguous file cache, right? Again, data on Arweave is made up of chunks, so there has to be something to assemble all of these. So the gateway is responsible for doing that, and it'll cache that in a local cache for really fast access. It'll do things like render your files, your PDFs, your JSON, your documents. It will stream your videos, your music, right? It will render your full apps and pages thanks to Arweave manifests, right? It'll provide this access optimistically, meaning if data has been uploaded through a gateway and it hasn't been mined on chain yet, the gateway will still serve that out, right? Because users and apps expect it to be really fast. And then finally, it's really providing an access layer for the rest of the Arweave HTTP API, right? So whether you're fetching prices, transaction information, wallet balances, you can do that all through a gateway. It features the domain name system RNS, so whether that's buying and managing configuring domains, resolving them, looking up IDs for friendly names, all of that is kind of baked into the DNS services. Gateways, as you might be familiar with, are also responsible for indexing all of that data. By default, a gateway will index everything on layer 1, but gateway operators have the ability to tune any kind of layer 2 index, whether that's specific applications or maybe just personal data. It's really flexible to do that. And then gateways provide a GraphQL interface on top of that to make it really easy to search for that data. And similar to optimistic caching, a gateway will take any of the data that's ingested through it, and it'll optimistically index that as well, so you can find it really quick. I have a box here for just general compute. Technically, these pieces aren't in the gateway itself. It does ship with an AO compute unit right now. That'll probably change in the future as things get more hyper-beamified. But as I mentioned before, you can use other chains for some of your smart contract work, right? AO is the native platform for the RIO network. But before AO, there were plenty of teams building smart contracts on Ethereum, referencing data stored on Arweave for NFTs and other things. And finally, the gateway comes with a set of some management tools, whether that's monitoring the gateway itself. It comes with a nice Grafana dashboard. It has an ETL process to extract any data, transform it, load it into the index. We use Parquet for that, so it's pretty interesting there. It comes with tools for content moderation. Each gateway operator basically gets to decide, right? That's one of the differences between a centralized cloud and this permanent cloud is the content moderation has been kind of democratized to all of the operators versus a single central controlled corporation. And finally, the last, and possibly one of the more important management tools in the gateway is the Network Observation and Reporting System, or the OIP. And that's what gateways use to monitor one another, report on the performance, the availability, uptime, and that's what determines what rewards the gateways received. So clearly, there's a lot of things happening in the gateway. It's taken us a long time to build all these pieces, but it's, similar to maybe AWS that has a whole suite of services for developers to use. I think a lot of you are probably familiar with RNS. I don't know, maybe raise your hand if you have an RNS name. Raise your hand if you've set it as your primary name. Okay, I want to see more hands up for that. But yeah, RNS is really one of the key features that and innovations that we came up with. Friendly names for apps, pages, data, identities. Maybe hash paths. I don't know if that makes sense. Maybe, Sam, I don't know, you got to think about that. You can buy a name with a lease or purchase it indefinitely, and all of those proceeds go to the gateway operators. There's no DAO, there's no central company that receives this and then decides how to fund things. It's all controlled by a protocol. So really unique to RNS versus other Web3 name systems. And the cool thing is it's not just a name for an identity, it's a name for data. So you'll be able to access it on any of the gateways in the network. There's, I think, 280 or so gateways. So whether it's rdrive.volanarios.com or rdrive.arweave.net, so on and so forth. It really provides a high level of resilience. And then if you're buying a name, you also have subdomain space, or we call them undernames. So you can deploy other applications, assign different identities. Similar to if you purchase a domain name, you might have many identities that leverage that domain. And then finally, we built a really easy to use app for anyone, but there's also a powerful SDK if you wanted to build your own version of this, whether it's buying names or resolving primary names, etc. Lots of names out there already. Here's just a few examples of the different front ends, apps, pages. Shout out to any of the teams who are on here. I did not mean to exclude anyone, but yeah, and now what RNS really enables is what we call the Wayfinder protocol, or AR://. So you can actually obfuscate the domain name completely by using this new schema. So effectively, you don't need to even remember what domain to access your data on. We released a little Chrome extension called Wayfinder that does this, but apps like Wander also have it built in. So you could just type in AR:// and your name, and it'll route you to a high-performing gateway. So what can you do with it? I mean, lots of things. We see a lot of websites and apps. I just showed a bunch before. Lots of different games are getting built, whether these are just the front ends or even the assets too. I know there's some folks in the audience working on some really cool games now. File storage, that was what got me into this whole thing with rdrive. The beauty of that is you have all this rich metadata for any of the files that are stored. So that could include things like your any information architecture or a license, right? Which is very applicable in today's day and age when content is getting scraped by these AIs and users are not necessarily they're not necessarily getting referenced by these AIs. So storing any kind of data has always been the sweet spot, and it doesn't have to just be static data. It could be NFTs or digital assets. Again, whether those are AO based or on other chains. So we see a lot of use cases. We're always trying to grow these, and this doesn't necessarily have to just be Web3, right? There's plenty of Web2 use cases as well. Again, the system has been operational for a long time. I know we just went into mainnet recently, but this is just an example, shows how it scales, right? 200 plus terabytes of data, billions of data items. We all see that number growing every month. And just an example of how many unique users are connecting to rweave.net. Almost 1 million on a monthly basis, right? So that's kind of crazy to think about. And sure, that's not people uploading data, rather uploading and consuming it, right? So it's great to see these numbers grow. But yeah, are you actually ready to build something on it? There's lots of tools that we have, whether it's the RAO SDK to integrate with RNS or the network. I have the wrong link there. You don't go to the Wander app for the RAO SDK. The Turbo SDK is for any uploading of data or paying for those uploads. Again, whether that's with a credit card or Rweave, Ethereum, more cryptos coming soon. If you're looking for a no-code app deployment solution, highly recommend R-Link. Again, I messed up the links here. MetaLinks is actually a nice little homepage builder. PermaWeb Deploy is excellent if you want to try a GitHub CI/CD integration, so you can update your app and then have those updates get pushed right to the cloud. And then we have all kinds of quick start guides for helping everywhere in between. If you're not a builder, that's okay, because you can still use this pretty easily. If you want to actually write data, of course you're going to need a wallet. Highly recommend Wander, the new rebranding of RConnect. Although, as I mentioned before, wallets like MetaMask are also still supported, and more support will be coming. RDrive, give that a shot. You can just pay with a credit card, make a little homepage like a link tree with MetaLinks. Of course, get a domain, and you can apply it to either your identity or your homepage, or even just listen to some music, right? I mentioned before, like, gateways are great for streaming. Someone built a little Grateful Dead tribute app where you can stream some cool tunes there. And this point is really, this is a cloud that's not just for technical people. Anyone could really use it. I slipped this in, just now. Just wanted to give some hints at what's coming next. After mainnet, it's been mentioned before, but we've been included in the PermaWeb Index. So really excited to leverage that as a way to distribute our tokens to the community in a permissionless, protocolized way. I showed the big chart with all of the different gateway services. Not all of those have protocol incentives, right? So we need to build out more of those. We need to onboard more gateway operators. We just completed the Gateway Operator Incentive Program and got, I think, 29 bigger teams and projects to run gateways. It's not going to stop there. We have a whole lot of hyper-beamification that we need to do, and we're still unpacking that and understanding how we could apply the different functions of a gateway onto AO Core, and how we can maybe leverage T's and some of the other features there. We're going to do a big push to integrate all of our tooling into third-party libraries. We've built a lot of stuff. It's time to get it out there and get it integrated. Now that we've launched mainnet, we are going to start a new grant program as well. So more to come there for any builders who have some really big ideas that they're looking to explore. And then really, it's just about adoption. Again, I see a lot of familiar faces in the crowd. I would love to see more people who I've never met before, right? So we're really going to focus on, getting new users, new developers, new founders, and just, broaden the usage of Rweave, AO, and the permanent cloud. Invite you all to obviously follow us, build with us, give a little QR code scan here, fill out our partnerships form if you're really interested in working more closely. And we'll be at the conference the rest of the week, so come say hi, and thank you.
record that I just set is currently updated with the record that I wanted to set. So just kind of checking afterwards. And one thing you may find is that when I set base names or I do deployments or anything like that, on the deployment, I do not build into the script the build then deploy, specifically because I want to see the size of the file or the size of the project before I deploy. Lots of times I've been building applications, I may forget, man, I just put this image in there and it's huge, it's 25 megabytes, and then I run deploy and I'm like, oh crap, like why is this build folder so huge? Make those modifications before it actually runs in there. So what you end up having to do is you end up simply just running the PNPM build. So you run the build, and then right after that, you just PNPM deploy. And that does your deployment from there. There we go. Okay, so we're all good, and all you have to do is just copy your transaction ID. Now, I want to go ahead and just set a undername in here. I've already preset some of that here, so I'm just going to change this transaction ID here. Save that, PNPM, and then set undername. There you go. So you've already, at this point, you've built the application. You've already deployed it. Then you've already set the undername. So at this point now, I can actually just run over here, go over to my undername, and we're good to go. That's super fast. Has anybody seen a fully decentralized front end deployed that quickly? I mean, that's really, really fast. So this starter kit is ready for you right out of the gate. So if anybody wants to use this for the actual hackathon, that's what I built it for. So for anybody that's building in the hackathon, I really, really encourage you guys to use this. Some upcoming features I'm working on is just more repos specifically for other ecosystems. I actually had a lot of fun yesterday at the Monad Hacker House. Grabbed somebody else's starter kit, added all these implementations into from their starter kit into mine, and then deployed that. And a lot of the Monad developers really, really loved it. So you're going to see more repos like that. You're going to see additional features, and instead of just being able to pay in turbo credits, you're going to see additional features of being able to pay in other currencies as well. And then last but not least, there will be some AO features in the back end pretty soon. I'm working on a repo that has that full stack application experience of having everything deployed on the Arweave ecosystem using a starter kit like this, but with AO functionality using AO Connect. And then last but not least, repos for NFT image deployment and transaction ID management. I mean, imagine having a whole folder of images to be able to drag and drop that and just run one single script and then have it save all of your transaction IDs or your URLs to those images in a manifest folder. I mean, that's the easiest, fastest way you could do something like that. So aside from that, if anybody wants to use that starter kit, it's right there. Go ahead and grab it from the QR code. And that's it, guys. I did that in 7 minutes, right? Yeah.
The coolest things I've seen, and I've seen a lot of cool stuff today. But that is not to say that what Tate from Community Labs is about to show couldn't one-up it. Tate, we're so excited to have you here, and people watching at home, people in the audience, I know we're at the halfway mark, so give it a big stretch and get ready for 2 more hours of some of the coolest stuff within Web3. Tate, take it away, man.
Thank you, Drew. All right. Thank you guys for having me. I wanted to start today off with a story. Our team has been building on AO for nearly a year and a half now, which is kind of crazy to think about looking back on it. But over the last year and a half, the state of AO has changed quite radically. It's become more stable, it's become more scalable, it's become more performant. But I was reminded recently of a movie that I watched probably 5 years ago. It was one of the Superman movies. And in the Superman movie, they were trying to understand, Clark Kent came in on this spaceship. They were trying to understand what the spaceship was made of. And essentially, thank you, Sam. Essentially, the spaceship, the scientists couldn't figure out what the spaceship was made of. And so there was no way to actually characterize it. They couldn't describe the material because it didn't exist on our periodic table. And after building on AO for the last year and a half, I continue being reminded that we are dealing with what seems like alien technology because of how far out in front of everything else in this industry AO is positioned as. So, we're talking about a lot of complex terms here, a lot of new concepts, new primitives. But the truth of the matter is, if we try to put it in the box of everything else that exists in crypto today, it just wouldn't do it justice because it is so different. And so that's one reason that I get excited about AO. I think I'm excited about building on alien technology. I guess that makes Sam an alien as well, a little bit. No offense. And I wanted to spend today to talk for a second about one project that we're really excited about that kind of pushes the boundaries of AO. Something that's been really cool, there are really 3 features inside of AO that we're especially excited about. TEEs, Weave Drive, and then WebAssembly. Maybe going through each one by one. Sorry, got ahead of myself. TEEs give you the ability to run computations in private, in a verifiable and deterministic way. Weave Drive gives you the ability to then go look at Arweave and fetch information. And that information could have come from anywhere. It could have come from inside of Arweave, it could have come from the web, and use it as if it were data on your own machine, which is like tremendously powerful. And then WebAssembly, so generalized compute in all kinds of different programming languages that can compile down into WebAssembly. It's sort of the standard outside of crypto, and now AO makes it possible to use inside of crypto, which gives you a lot of abilities. I'll go into that. Putting it together, though, one of the interesting use cases is building agents that are capable of signing and posting transactions from inside of AO onto other blockchains. Agents are really cool in crypto right now, and it's insane that you can actually build an agent to interact on other blockchains inside of AO as a decentralized supercomputer. So how might you go about doing that? That's some research that we've been doing. The first step would be to generate private keys inside of the TEE. The reason a TEE is helpful for this is because if you're generating a private key and publishing it to a blockchain, generally that information would be public, and you don't want anyone to have access to your private keys. A TEE is perfect for this because you can create an environment where those keys can be generated deterministically in a verifiable way without being revealed to the public. The second thing you could do is you could leverage Weave Drive to read data from Arweave about other blockchains. So for instance, Redstone is uploading a lot of data about other chains into Arweave. Kive is doing the same thing. We can pull that data into a process on AO through Weave Drive and use that to be able to make decisions. For instance, if we're building this cross-chain agent to trade, you can make trading decisions off of it. And then third, the intelligence. So WebAssembly, WASM64, it gives you the ability to take large language models like Llama in C++, compile them into WebAssembly, and then run them inside of AO. Huge, like you can't do that anywhere else by a long shot. And so we're really excited that that's possible in AO because it enables these processes to make decisions that are informed off of data from other chains in a way that is cost-effective, super fast, and decentralized. And then fourth, you can also generate and sign transactions with those private keys. So once you've figured out the decisions that you want to make, you have to assemble a transaction and sign it. You can use the private keys that you generated inside of the TEE to make that possible, which you can then cryptographically sign. You can also use like MPC technology if you wanted to make that even more secure. And then fourth, you could use some type of oracle to take the data that was returned to you from AO to post onto another blockchain. Or you could do it yourself if you wanted to. That's really insane. You can make Bitcoin transactions or Ethereum or Solana transactions from inside of AO. Why does this matter? Everyone is talking about agents right now, but all of the agents that people are talking about are evaluating things off-chain. They're making decisions off-chain. They're running on centralized servers. They are not inside of crypto. They don't really act in Web3 aside from the fact that they're generating transactions and posting them. It's not scalable. It's if anything, it's false marketing. And AO is the only place where that can be done on-chain. One more just fun tidbit, I guess. We've been working really hard on building a better user experience for accounts inside of AO. Obviously, Community Labs is the team behind Wander. Thank you to everyone on our team that's made that possible, and thank you to the community that has also adopted it over the years too. Excited to announce that coming soon there will be a single sign-on option introduced that will make it even easier for your consumer-facing application to generate Arweave wallets and make transactions with a UX that is equivalent to Web 2, but with all of the advantages of AO and Arweave in Web 3. Thank you. With that, I will hand it over to Liquid Ops. Appreciate it.
Hello, can you hear me okay? My name is Lorimer, and I'm the founder of Liquid Ops, which is a lending and borrowing protocol built on, all good? Sorry. So my name is Lorimer. I'm a founder of Liquid Ops. We're a lending and borrowing protocol modeled off of Compound V2, built on Arweave and AO. Okay, so a little bit about our story and how we got here today. Me and Martin had been working in the ecosystem for quite a while. Martin has kind of been in since its infancy. And one thing we both realized was that we held Arweave personally, as well as previously I was a fellow at Community Labs. I worked on a project called ETHDenver, basically a way for anyone to be able to come into Arweave with a Google account, Twitter account, and actually be able to onboard into the permaweb without the use of a private key. So we held Arweave personally, and we also had a lot of people coming into our project's Discord. Martin running the RConnect one, me with the ETHDenver one, and one of the biggest things that they all had in common was so we hold Arweave tokens, how can we actually earn yield? How can we use this liquidity in different products? That kind of just got us thinking about how can we generate yield? At the time, the only way to really earn yield in this ecosystem was contributing to liquidity pools on DEXs. And all this is super cool to do. We really wanted to have some of these more advanced products that you could see in places like Ethereum actually in this ecosystem. Kind of going into how Liquid Ops works, I think there is a huge misconception of, where yield actually comes from in a lot of these different protocols. Some projects they mint tokens and give them to their users. Liquid Ops, essentially, it works off of three kind of parts you can think of it. So you have lenders, like me and Martin, that held Arweave, like our users, that wanted to actually earn yield on those tokens. So for them, it's super simple. You basically take their tokens, you add them to a pool, and basically make them available to be lent out. So that really brings us to where the yield actually comes from, which is borrowers. I'm going to go more into some of the borrowing products in the next slide. At its core, basically, you take the lender's liquidity, and then you allow borrowers to actually use that liquidity in different products. So we're an over-collateralized lending and borrowing protocol. So the whole idea is borrowers basically have something called a loan-to-value ratio. You often see it as LTV, which basically just means that in order to borrow on Liquid Ops, you need to add collateral. So for example, if the loan-to-value ratio was, say, 2 times, for every $100 you borrow on LiquidOps, you basically need to add $200 worth of collateral. So, someone would lend into LiquidOps, those tokens would be available to be lent out to borrowers. Borrowers would add collateral to LiquidOps, and then the loan to value ratio would determine how much they can borrow. So yeah, though that's kind of lending and borrowing is really simplest form, but now we have like liquidators. So say you were like borrowing in traditional finance in Web 2, say it's like a mortgage. You go to a bank and you say, I want a mortgage, and the house actually acts as collateral. If you didn't pay your mortgage, the bank would repossess the house and pay off the debt of that mortgage. Similar sort of thing with like payday loans. You get KYC'd, and then obviously if you don't pay back that loan, the government comes after you and knocks down your door. So with something like lending and borrowing protocols, basically, if the collateral drops below a certain loan to value ratio, a liquidator has an incentive to basically buy the bad debt off the protocol, and then basically, have a fee be imposed on the borrower. The liquidator gets that fee and basically repays the initial loan that the borrower took out. So yeah, really simple, its simplest form, that's basically what lending and borrowing protocol is. So yeah, going into some of the things we can create, and this is the really exciting part, apart from having lenders be able to actually earn yield on their tokens. So we're kind of focusing on three main points at LiquidOps. First one being like leverage, actually being able to enable people to trade with more than they have via like leverage. This is kind of like the basic stuff, being able to long tokens and actually be able to plug that liquidity into different trading avenues. So that's kind of like at its kind of basis what LiquidOps enables with products. So yeah, the second kind of thing would be vaults. In chains like Ethereum, you have really, really advanced DeFi products that we basically want to port over into this ecosystem. The way I quite like to think about it is we're like an island of liquidity that has never really been used in DeFi. And through the rise of AO, we really think it's going to be a super, super interesting concept to be able to develop these things like vaults. So all a vault really is at its core is like, imagine, instead of lending into like a liquidity pool, you can lend into a vault that has a certain predetermined strategy. So it could be like an arbitrage vault. So what you could do is have a vault basically on LiquidOps where you could lend into the vault. And then behind the scenes, say you lent into this vault, you borrowed, say like Astro USD, and you added Arweave's collateral. You then swapped that Astro USD into like, I don't know, USDC, and then deposited that USDC into Aave. You've basically got an arbitrage where you can utilize your Arweave tokens actually on these, these projects like Aave. So yeah, being able to basically have these customizable vaults in this ecosystem, we're super excited about, meaning that effectively, we'll be able to bring some of the yields that we've been seeing in Ethereum to this ecosystem from day one. And yeah, shout out to Autonomous Finance for that really cool image of an agent. So this kind of takes like the vaults concept, but really, really brings it into what we're trying to do in this ecosystem with a hyper-parallel compute network. So actually, we're going to be creating these things called like intelligent vaults, kind of smart vaults, where, instead of having like a strategy, that just goes kind of like an arbitrage strategy, you can pair a large language model that actually learns adapts over time using this liquidity that people want to be able to lend out in these different kind of more advanced products. So yeah, that ties us quite nicely into, I think, our mission with LiquidOps at the minute. And yeah, really the first one would be bootstrap the liquidity we have in this ecosystem. This like kind of island of liquidity that's being untapped in DeFi. Be able to, create some incentives for people to come into the ecosystem to, earn yield. I think, a really good validation that we've had recently is the staked Ethereum and DAI bridge. One of the first times where, as an ecosystem, we've been able to have like a really, really interesting incentive for people to pour assets over into this ecosystem. So at LiquidOps, we really want to carry that on and sort of, have the cherry on top that, for example, if you come into this ecosystem with DAI, you can earn a new portion of AO, and then you can also lend the tokens and earn that interest, or you can, use some of these different products that we're going to make. And yeah, obviously yield, being able to earn a sustainable yield on your Arweave token. tokens, like me and Martin initially had, and our users, being able to, have a really cool, sustainable yield for the foreseeable future, like we have in some of these other chains. Enable those new DeFi products, like, being able to actually trade with leverage in this ecosystem natively, and, being able to, plug that liquidity into these different strategies that have found product market fit in other ecosystems, and being able to pair the liquidity we have with actually, things like autonomous agents, I think is going to be super, super interesting. Thank you very much. Recently, we just shipped our testnet. We're kind of gathering feedback on, what this ecosystem kind of wants with lending and borrowing. Feel free to check out these links, as well as I will be doing a talk in the next, little bit of more specifics of Liquid Ops and giving a little demo on it. But thank you very much.
Thank you so much, Lorimer. It is a Community Labs Palooza up in here because next we have Kadar. Kadar, take it away, man.
Hey, everyone. Thanks for having me. Let's see if I can do this. I'm Kadar, founder of Astro Labs. I'm going to talk about driving liquidity for AO and what that takes and what we're doing on our side of things. So, I could talk about AO, but I think Sam and Tate and everyone else kind of covered it. So, let me just cover the basics. AO is a new city that requires new utility, and essentially it has unlimited potential. But one of the key things we think it's missing is liquidity. So that's what I'm going to talk about today. So for any economy, you essentially need a way to transact, save, and essentially navigate the ecosystem. And we think we can build a robust model around Astro liquidity pools, stablecoins, and kind of yield generation activity, and kind of bring a lot of value to apps like Bottega, Liquid Ops, and GameFi, SocialFi, anything like that. I'm going to get into a little bit of what that takes. Honestly speaking, we kind of need it. Right now, we're transitioning to mainnet that has a lot of quirks, but is going to be more scalable, meaning that we need liquidity infrastructure that's also scalable along with the chain itself. And that's what we're going to try to build. So why does liquidity matter? Any functioning economy, doesn't matter if you're a blockchain, a city, a country, you essentially need a way for movement and value to be exchanged, and the Permaweb needs a stable value and liquidity infrastructure, and that's what we think we can build. So essentially, this is how we think about assets, liquidity, and we want to create this little flywheel. We're going to start with assets first, stable value second, yield generation, and then value share with ecosystem apps, developers, builders, agents, and then we're going to create more assets and kind of kick this flywheel into gear so everything kind of keeps rolling. And right now, that's what we think we can start with USDA and partners like Bottega, PermaSwap, and Liquid Ops, of course. So we're thinking about stablecoins a little differently. We think in the early days, we need to kind of bootstrap and unify liquidity and kind of have all dollars, all chains into one stable on AO so liquidity doesn't fragment. We can see a clear example right now where liquidity is kind of fragmenting between QR and WAR. Some people use Quantum, some people use AOX, and we think a better model would be to essentially introduce a way to defragment. And that's what we want to do with USDA. It's going to be a unified stable dollar on AO, and we're going to push liquidity to its extreme, essentially unifying everything. So if you want to trade, save, transact, if you're an agent, if you're a user, if you're a builder, USDA would be the deepest liquidity pool you can use and access and essentially capture value. So high level, I'll send you a couple of documentation if anyone wants to nerd out about liquidity, but we want to build what's called a liquidity engine and kind of have three pillars to this engine. First is going multi-chain, having multiple pathways into AO. We want to create a on-ramping gateway. Essentially, we need a way to connect the real world to AO. Right now, getting into AO and RE is really tricky, and we think we can cover this pillar very easily with USDA. And the last bit is around tokenized assets. I know no one wants to hear it. We're all about the tech, but we need more assets on chain. Everything's been tokenized. It's time, stocks, everything. And we kind of want to bring that engine into AO, allowing different ecosystems and different economies to exist on top of AO, whether you just want to trade stocks or different assets, or you want to build social apps or games. Right now, there's a few apps live on AO LegacyNet, and we think they're going to transition to mainnet and more apps to come. But the kind of key areas we're seeing is marketplaces, launchpad, DEXs, lending protocols, and social. I haven't mentioned gaming. I think you're going to be the first gaming app, or maybe second, but that's going to be an interesting category for us as well. What USDA does differently is essentially we capture some value by the collateral locked in USDA, and that's what we're going to bring to apps that are adopting USDA, kind of having this shared value exchange, and then kind of kicking off this flywheel where we capture revenue instead of being extracted by other centralized stablecoins. We're bringing that value back to the ecosystem, and then apps can kind of, again, use that to expand the team. They don't need to fundraise as much. Of course, there's AO funding raise, but we think we can push that to the extreme by having stable yield generation brought to AO. For app builders, there is a savings rate to be brought at some point in time for users of the chain, but you can go anywhere to get savings rate. We think on AO, in the early days, we need to bootstrap early developers and teams. We've been saying USDA is coming soon for the longest time. It's coming soon this time, and I think within a couple of weeks we can announce how USDA looks like, what version 1 looks like, what version 2 looks like, and we're going to be working with key ecosystem teams like LiquidOps, the Autonomous team, and PermaSwap team to essentially bring USDA to liquidity pools so people can trade, save, essentially capture value in native USDA on AL. These are some of our launch partners, including Community Labs and Wonder, and we think we can push this to the extreme by partnering with teams that are native to the ecosystem, that are here in the beginning and will be here a decade from now, and that's what we're building towards. We're pushing some updates, let me be honest. Quantum has been finicky, but we're pushing some updates over the next week or two to update the user experience, update how it works, the speed of execution. And when we launch USDA, we're just going to revamp the whole platform and kind of launch version 2, which should allow you to bridge any asset across at least 4 or 5 chains we think we can support by implementing a new intent framework. We haven't been publishing a lot. We've been kind of heads down building, but soon we'll be starting to publish light papers, white papers on how the intent layer would work into AO and kind of the model we're trying to complete. Try Quantum, reach out to me on X, Telegram, reach out to Tate, I guess. He'll let you know what my details are. And yeah, thank you for the time, and I think that's it.
Okay, guys, I don't know about you, but I could go for a Huel right now. Anyone got one for me? Sam? No, not so much. Our next speaker is Ms. Wenshin Turing, talking about the future of sovereign finance. Wenshin, it's a pleasure to have you.
Hello, everyone. My name is Turing. I'm from RV SCP Ventures. I take in charge of the investment here. And it's very happy to see many old friends and new friends here. I'm very excited to introduce you FusionFi protocol and its native token, FFP. Before we get started, let's think about one question. If DeFi is truly decentralized, why do users need to deposit their funds into a smart contract? In protocols like Uniswap and Compound, users need to authorize their funds, but FusionFi protocol will completely change this. FusionFi protocol represents a new model in decentralized finance, the 4th generation DeFi, which solves the interoperability issues of traditional DeFi, will bring a new concept of individual finance sovereignty. Unified settlements via node flow across asynchronous network, especially AO. After years of development of DeFi, DeFi have different stages. From 2018 to 2020. So they're only decentralizing some basic finance information like Uniswap, RV, and also Compound. Then the 2nd generation DeFi comes here, improving capital efficiency, such as Olympisto, TokenMat, and also the 3rd version of Uniswap. When time comes to the 3rd generation DeFi, it's almost after 2022. enhancing the collapsibility, such as eigenlayer, Pendle, and Radiant. Although DeFi has improved, it's still facing some limitations. Let me give you some example. The liquidity fragment. So different protocols have different liquidities. So make them very hard to get efficiency. So the result is a very low capital efficiency. And users are also restricted. So every smart contract has their own rules. So the contracts take all through the financial operatings instead of controlling by users themselves. And also lack of interoperability. So different protocols follow different rules, and it's really hard to integrate. To address all these issues, Fusion 5 protocol was born. But how Fusion 5 protocol works? Fusion 5 protocol is not another DEX or learning protocols. You can think of Fusion 5 protocol like a financial Lego kit. You know, the secret weapons are nodes and agents. You can imagine that the nodes are a universal market, universal money. You can trade, learn, earn all in one language. No more conversations. So all the operations are based on node flow using a common data structure for simplification. And unified settlement layer enables cross-protocol and cross-financial scenarios interoperability. And everybody knows the ability of AI agent is very powerful. And AI agent is your robot assistant. You can set your rules and make them to execute, and funds still stay in your own wallet. Users can create their own financial agents without need any custody. So, for example, let me give you an example. If you swap token A to token B and borrow them on Aave, normally they will need 5 steps and 3 approvals. But with Fusion 5 protocol, there only will be 1 step and 0 approval. So that's what Fusion 5 protocol do. Why it matters? It's about Fusion 5 protocol solve the problems of interoperability, and we do care of the user sovereignty, and we improve the capital efficiency. But Fusion 5 protocol is not just a concept. It has real applications. For example, PermaSwap. The biggest DEX, AO native DEX, and has a very large transaction volume. And PermaSwap, you can set your own fees, funds stay in your wallet, and the profits will come directly. And also Legend. Set a bank, you can set the rates and let all the AI assistant to help you to management your funds. And also Rainbox. Rainbox is an AO native Minecraft game and easily to build an integrated trading marketplace with Fusion 5 protocol. You can think about that in the future. Every DeFi protocol can upgrade with Fusion 5 protocol, just like upgrading your network to 5G. And that's what's going to happen in the future. Let me give you some data about after Fusion 5 protocol launch. And after protocol launch, just about few weeks, there are over 29 million total settlement amount, and PermaSwap volume is just over 18 million. And over 75% of AO volume is in PermaSwap, and AO liquidity is over 67%, hits 4 million. So I believe that in the future, Fusion 5 protocol and PermaSwap will have some impressive data performance and to continue to maintain the leading position. And also, for sustainable development, we do have governance token. The role of the F5P token is to incentivize the protocol participants governments the ecosystem development, and also backboard the fourth generation of DeFi. Fusion-Fi protocol and FFP token, you can imagine that FFP token is just like the furrow in the ecosystem with the fair rules. As you can see that there's no VC and no team allocation. The total supply will be 18 million, and 5% is for airdrop for the early adopters because they made a great contribution in the past few months. And 1% is for initial liquidity, and 94% is trained to mine. So we do have halving cycles. So the supply will reduce 50% every 4 years. It's just like the Bitcoin model. Scales like Bitcoin, the early bird wins. And we do have incentive about the transaction is mining. So the more you trade, the trade to mine every time a node is settled, the creator receives FFP as a reward. And 94% from trade to mine, more trades, more FFP. And you can also stake FFP to gain VFFP tokens, and you can also vote like a shareholder. And all the profit generated by the protocol is stored in the treasury and funded by the settlement fees. So by staking FFP tokens, users can obtain VFFP. It's just like the Curve's VFFT token model. So in summary, FFT token is not just a reward token, but also a government tool for the long-term and sustainable development for the Fusion-Fi protocol ecosystem. So Fusion-Fi doesn't kill Uniswap and Aave, but make them better. In the future, everyone is their bank, exchange, fund manager, and this is the fourth generation DeFi. So will you still keep trusting others to manage your funds, or take control by yourself? Together, let's explore the future of decentralized finance. If you are interested in Fusion-Fi protocol, please follow our official Twitter here, and you can also scan a QR code to join our community here. And we hope to build with you together. Fusion-Fi protocol is all you need is the fourth generation DeFi. Thank you very much.
We have people from all over the world coming here to speak at our conference. Appreciate you so much, Turing. Next up, we have Alan from Randau. Alan, I can't wait to hear what you have to share. Thank you so much.
Thank you. Hold the mic. Can I pull it out? Yeah. Okay. Okay. All right, let's get started here. Sure. All right. Good afternoon, ETHDenver, and especially good afternoon to the Arweave AO community. I'm Alan, and at Randau, we are solving the on-chain randomness problem once and for all. Before I get started, I do want you guys to answer a quick question. Heads or tails? If you think I'm going to flip heads, go ahead and raise your hands. All right, and tails, who are my tails? All right, about 30% tails, interesting. Let's see. That wasn't a good flip. My flipping is a bit off today. There we go. Sorry about that. We got tails. Now, that was interesting. As the coin was in the air, we were all very uncertain of what the outcome would be. And what's also interesting that we we weren't able to influence that outcome once we'd flipped. That is the heart of what randomness really is. And at Randau, sorry, if only it were as simple as flipping a coin to generate randomness on-chain. The on-chain randomness problem has really plagued the crypto industry for years at this point. When we first started out, we were trying to use math.random, which really is more like math.pseudo-random, which doesn't quite work in blockchain since it's a public, open, and transparent environment where you could already see the seed on chain. Next up, a few people tried to use the block hash, which made some sense initially. It sort of starts to make sense as the block hash, it's a hash, and the hash output is typically random. However, when we get down to it, miners have the ability, or validators have the ability to influence that block hash. So that wasn't quite going to work for us. And more recently, the crypto ecosystems come to use oracles as a solution for randomness, which works to some degree. Unfortunately, one, they have high costs for no particular reason, and they're centralized. You actually have to be able to trust that oracle and that they're not going to use their prior knowledge of the randomness beforehand to gain some advantage. At Randau, we're solving the on-chain randomness problem like no one has ever seen before. We are crowdsourcing random values and aggregating and verifying them on-chain. With our horizontally scaling economic security model, we're able to guarantee that no one in the world will be able to predict or manipulate our random outcomes. Let's find out how we do it. You might think these two are a bit familiar. Here we have Morpheus and Agent Trunk. We're going to run through a few scenarios to understand the security components that exist in Randau's protocol to generate us high-quality randomness. So first up, both of these individuals, Morpheus and Agent Trunk, will have to post an amount of collateral, which we'll be able to incentivize them with. In a simple solution, Morpheus may just post a random value on chain. We'd wait a sec, and subsequently, Agent Trunk would post his random value on chain. With some of the properties of entropy, we're able to effectively say that random plus random equals random, a new random value, that is. Some of you may have noticed that we have to remember here, it's Morpheus and Agent Trunk. Agent Trunk he's malicious. If he sees any opportunity to manipulate or predict the random outcome beforehand, he's going to take it. And once Morpheus has posted his value onto chain, Agent Trunk is able to see that value. And he can change what he's going to post to chain in order to be able to predict the end output, which is not a final solution. How we've solved this problem at Randau is actually very interesting because we use AO's hyper-parallel capabilities to be able to do it. Instead of posting Morpheus's direct random value onto chain, what he'll do is he's going to post a time-locked box. And that box, it has a timer on it. Once the timer expires, the random value within it will be revealed to the entire world. Now, Agent Trunk doesn't quite have an opportunity here, does he? Because he can't see the random value inside the box. And an additional component here is that if he waits too long, if he waits until Morpheus's box has opened itself, then he's going to be severely penalized by that collateral that he posted earlier. So acting in his own best interest and the interest of the protocol, Agent Trunk will have to post his time-locked box on the chain. As this continues, the timers both expire and release both of the random outputs. which then we can aggregate and verify them all on chain. That solution was solid. It would work. It would be secure, and we would be able to have fair random values. But at Randao, we went a step further. We understood that our users were going to need quick, fast random values, and they weren't going to want to wait for those boxes to open. This is where AO's hyper-parallel capabilities come into play. Since AO has parallel processing abilities, we're able to create a key. That key is a verifiable delay function, which allows us to open the box after the fact, but before the timer, assuming all parties have already posted and committed to their random box. With the values opened on time, we'll be able to generate our new random value just like that. And what's truly amazing about this protocol is that its economic security scales horizontally. As more node runners are added to the crowd, we have additional security per their economic stake in the protocol. And the most amazing piece is that it scales any honestly. That means as long as there's a single honest actor, a single agent, a single Morpheus, and a crowd of Asian trunks, that we're able to hold economic security. This is unlocking new possibilities across AO for types of applications we couldn't see before. Non-deterministic, decentralized applications. We saw a few of them here today, and I was adding to them in the list earlier, where we have gaming all over AO. Gaming has all sorts of aspects, like critical drops, or critical hits, loot drops, and plenty more. We have artificial intelligence, where Apis Network was able to place AI on chain, but they mentioned themselves that they couldn't have a random component, which they could benefit from. We can have lotteries on chain, raffles on chain, and most recently we've had a few randomized NFT mintings, which is very, very fun. If you want to learn more about the deep cryptography behind Randao protocol, check out our white paper. And if you want to find out more updates, check out our Twitter. And if you want to run a node or be a developer and use our random values, check out our website. And of course, remember that Randao RNG is making on-chain randomness as simple as flipping a coin.
Whoa, Alan's got fans? Where's my applause? Just because you did that, guys, I'm gonna give you a 10-minute break. We'll resume here at 6 o'clock sharp, so if you need to take a stretch, go to the bathroom, we're gonna take about a 10-minute break, and then we'll power through the last hour, just because you were so kind as to give me applause. All right, see you in 10 minutes.
Tickle nodes into doing things right. Up to do with for do with for do it do it do with do 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 up do if for do if for do it do. You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high speed, high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullify spaceships. Story, flurry, hack, flurry. Mark's making moves before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Blood eyes everywhere, not just 3 bird phones. Quantaries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Bend it up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaps at the after party, sipping TLS tears. Call me well connected, I call it
Guitar slide. Wah, wah, guitar slide.
coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Get homemade in 7s for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the boot fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age, old as speak, young as each block mine down. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's RAM stains. Calling me mad, but mad's just a beta test for BUIDL. Oh, he just got to do. 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 and fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we BUIDLet the city on sports and chains. We BUIDLet the city with regen brains. We BUIDLet the city on sports and chains. No rug pulls, just pure on chain. Just stay seated, the Etherverse will leave you heated. We don't need your legacy, cause regen memes are brew upgrade. BUIDLet the city on sports and chains. We BUIDLet the city with regen brains. We BUIDLet the city on sports and chains. Rolling up and slapping chains. She's a Colorado Comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking Ethernight whiz. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Squine, her shield's a disco wall, fracturing legs, grass,
We'll be starting in 1 minute. Starting back in 1 minute.
Alliance architect with a bluff accordance grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralize this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves.
Okay, ladies and gentlemen, we are getting ready to get kicked off again. Man, these seats are super underutilized. Very comfy. I should have been sitting here the whole time. We've got a couple more workshops for everyone. Lorimer is back to do a deeper dive. Lorimer, can't wait to see it.
Okay, cool. Hello again. Yeah, so in this demo, I wanted to give basically an overview of LiquidOps, have a little look at our testnet, and try to speak about more of really what's under the hood and really how it works. So yeah, just waiting for the video to load. Cool. Okay then, so this is basically our main UI. This is where people will be able to come to LiquidOps, basically have a little look at each different market. So right now in testnet, we're working with Quantum Arweave, USDC, and Staked Ethereum. So yeah, you'll basically be able to see how much has been deposited into each market, how much is available at the current time to be able to lend and borrow. You'll be able to see how much the interest is, as well as have a little overview of the amount of assets that you've actually lent. Also be able to see your borrowings. So yeah, then here you'll be able to basically, change the token you're currently viewing. So in this example, using like USDC and Arweave, and then top right, basically click, I have a dum-dum as my profile NFT. We're using actually the Bazaar ID SDK to be able to, you'll have the same profile on LiquidOps as well as Bazaar. So yeah, okay, so that was the homepage. Pretty simple, I think. This is really going to be utilized by kind of consumers that really just want to lend into LiquidOps. And yeah, here you can kind of see like the markets, what LiquidOps' TVL is. We're in testnet right now, and hopefully one day have $30 billion in TVL. So yeah, you'll be able to see basically, the markets, the current assets that have been borrowed in the current market, and also amount that has been lent. And then, here you'll be able to basically claim testnet tokens. Okay, so that's basically, if you're a normal lender coming into LiquidOps, that's basically what you'd see. So if we want to go and have a look at, lend into LiquidOps directly, all you'd need to do on the UI is basically click the Supply Assets button. That opens you up to this portal. Okay, so what's going on here? Basically, all this UI does is build the transaction. So you basically figure out how much you want to lend into the protocol, what token you actually want to lend, as well as be able to see the interest you're going to get and have a little look at the fees. So what we do on this UI is we use the AO Connect SDK to basically build the transaction of all of the data and send it on chain to AO. So the nice thing actually about building an AO and the way we've architected LiquidOps is that you can just be a normal person with like an Arweave wallet like Wanda. You can use this UI and lend into LiquidOps. But actually, different processes can also lend into LiquidOps. So if you're an autonomous agent and you have, I don't know, like I've seen some really cool kind of autonomous agents in other ecosystems. Like I think one's called like Eliza or something like Layla. And like I remember a tweet, I think it was by like Brian Armstrong. He was like, we can give you Eliza like a wallet. And natively in AO, because processes can custody funds, that could effectively mean an autonomous agent could choose to lend in LiquidOps. So yeah, basically here we're trying to figure out how much we're going to lend into LiquidOps and just basically confirm all of the different data associated with this transaction. So on the back end, basically in LiquidOps, kind of how it works is we have two main processes. So we have something called an O token, and we have something called the controller. So as we're modeled off of Compound V2, basically, the O token is like a C token. We're called LiquidOps, liquidity operations, so kind of an O token is an operation token. This is the receipt that you get when you deposit into LiquidOps. That basically it's a claim and it's a yield generating asset. So if you hold like O Quantum Arweave, for example, that is basically a receipt of depositing into LiquidOps and earning interest on that token. So yeah, basically O tokens, whenever you send funds into LiquidOps, they are then sent back to the user, and then they can use them in different DeFi avenues. So yeah, pretty basic there. There's not many, there's not like many other things really to it. Then all we really do is whenever someone deposits into LiquidOps, we give them back this O token. So if you can imagine, once a token's been lent into LiquidOps, basically, you'll be able to see your balances, see how much you're earning, and on our back end, those tokens will then be available to be used in loans. Again, if you want to like unlend, you just click your kind of asset section, and you'll be able to actually unlend that token. Okay. So this is where it gets more interesting of LiquidOps' architecture, the borrowing. So kind of what we've touched on right now is we've lent into LiquidOps. The protocol has issued us an O token, a claim to that initial lent token. So borrowing is a little bit different. So as I mentioned in the last presentation, we're an over-collateralized lending and borrowing protocol. So actually you need to add collateral before you are able to borrow. So the way you add collateral is exactly the same as the way you would lend tokens. So yeah, you lend into the pool, and then that basically is collateral that you can borrow against later on. So yeah, exactly the same as if you were lending. You build the transaction, figure out how much you want to lend and borrow. You can have a little look at your current position summary, sign the transaction via Wanda, and yes. So once that transaction has been sent, we actually don't send it to the O token. What we do is whenever we want to borrow, we send it to the controller. So all the controller's job basically is to do, as we are cross-collateral, is to have a look, have a look at the loan-to-value ratios of the token you're trying to borrow. Ensure you have enough collaterals to suffice that borrowing amount you want to do. So back to the example, if you want to, if the loan-to-value ratio is 2 times and you want to borrow $100, you need to add $200 worth of collateral. So the controller process basically requests via an Oracle. Just via a message from our controller process to the Oracle process, price feeds for whatever you're trying to borrow, and is able to then compare the loan-to-value ratios. And then if basically, you have enough O tokens deposited into LiquidOps, and the Oracle has come back that, the loan-to-value ratio is fine, we basically are able to issue that loan. So yeah, being at quite early stage, and lending protocols being, we basically have architected this that in the early stages of LiquidOps, there's a lot of security concerns that basically come into that. So as a protocol, we have basically set out a certain criteria to basically deter potential vulnerabilities with LiquidOps. So one of them being we limit the amount of lends and borrows you can do within a certain time frame. Basically, this is to not overwhelm where AO is at the minute, not to allow spam to be a reason of a vulnerability. So yeah, whenever we have checked the loan-to-value ratios, we also check that your wallet address isn't spamming LiquidOps, as well as we have a queue system that basically means that things happen sequentially, one at a time, rather than if someone see you as faster than the other, they can have their transaction first. So that's one of them, limiting in timeframes, but also limiting the amount you can lend and borrow. So yeah, I don't really want to say the project's name because I think they're here, but one project quite recently, within the last couple of years, it's actually made a very, very good comeback ever since this. They suffered the vulnerability of basically a flash loan attack. So what happened is someone borrowed just a ridiculous amount from the liquidity pool, and basically didn't pay it back because the collateral was manipulated on another exchange, and it basically meant that effectively their collateral that was worth nothing because the token was ridiculous got liquidated, and then they basically just kept the loan. So yeah, limiting the amount that you can lend and borrow in one transaction, as simple as that, actually would have deterred this type of vulnerability. So yeah. Okay then, so yeah, basically now, you'd be able to confirm on the UI that the amount has been borrowed. So, Back to the last presentation, talking about some of those products we can create, leverage trading using it in vaults. We have a really, really simple SDK that, developers looking to trade will be able to integrate into the applications, as well as natively on AO, having some of these agents be able to send messages directly to our processes, rather than having to go via Web2 via a normal TypeScript SDK. Okay then, so moving on, liquidating. So we want to have a kind of diversified liquidation, I don't know if the word's kind of arena. We're not only going to work with a certain type of liquidator. Sometimes liquidators are really just market makers, and I think that's actually quite unfair to the typical Web3 user. Because actually liquidations in itself could be its own product. You have some other protocols where you can have a vault. There's a liquidation vault, so people can deposit into that vault. They'll be able to actually liquidate other users on LiquidOps. and actually generate some of those fees and have it be its own yield generating vault, a liquidation vault. So yeah, we're going to be working alongside market makers, some of these vaults, and then hopefully autonomous agents once agents sort of mature, to be able to liquidate users as well as normal people coming onto the UI and being able to see, oh my God, there's an ability for me to make a 10% on the amounts being liquidated. So yeah, we've kind of taken the traditional swapping UI, basically here you have the normal Uniswap swapping UI, and say if you wanted to liquidate, in this case we're liquidating staked Ethereum, so we're sending one Arweave that has originally been lent out. The collateral has hit that loan-to-value ratio that triggers a liquidation, and then obviously, the user would basically be able to see here how much they're sending, and then here be able to see how much they're getting back, and then obviously here it'll be like the profit. But right now there is no active liquidations on LiquidOps. So yeah, that's pretty much it. So we right now, like I said, we've shipped our testnet. Now we're working on integrations with liquidators, integrations with borrowers, and also potential avenues of where we're initially going to get some of those lenders. So yeah, I'll be about until the end of the week. Feel free to come and ask me any questions. But yeah, thank you very much.
We're at the point in the conference where I'm just going to start shouting people's names when they come up to speak. So here we go. Greg!
Did you go into mirroring, I think, or?
All right, can you hear me all right? Thumbs up in the back. All right. My name is Greg Albritton, and I am a part of the AO Computer Club. And today I'm going to be talking about fair tokens. Now, most of you here know about fair tokens. However, I feel like it's really important to emphasize it as a kind of source of camaraderie. In the AO ecosystem, we have an amazing opportunity to do something different. Something that was done many, many years ago through Bitcoin, and something now that we have access to thanks to the token distribution and the fair launch of AO. And this is really, really exciting to me, because one of the things that attracted me to Arweave several years ago now was this high degree of integrity, right? We're looking to preserve history, all kinds of history, all types of formats, digital and so on. And today, we're looking to provide opportunities across the board for individuals and not have these backdoor deals as a primary motive. So I think fair tokens are friendly tokens, and I think it's important that we emphasize this and kind of cheer behind this movement, if you will, if we can make it one, which I think we can. So here is a bull. This is Kintsugi. You may have seen the check. All right, you may have seen these types of bulls. What's really cool, and the reason why I have this on the screen, is that tokens have been broken. All of these things in the limelight today are incredibly problematic, right? It's not fair by any means. Individuals are getting rug pulled and all of this. And I think we have an opportunity here to make things much better from a broken system. And there's real beauty in the opportunity here, and that's where you see the gold inlay from the broken pieces of this bowl. Tokens are really having a moment, and I think this is the opportunity for AO and the AO ecosystem, right, which is fresh, for us to kind of put our foot down and say, this is actually how you do things. This is the way that you actually get fair, inherently high integrity token distribution. And I think this can be an amazing motivator if we really come together on this. Imagine if an entire ecosystem was based on that, and that's what AO is, really. So AO, the fundamental token, is a fair token. You can see the stats here. 21 million supply, just like Bitcoin. Nice, smooth halving schedule, like all of these layers. And in addition to that, there's some real cool distribution mechanisms here. Just by holding R, you get AO, right? And then for those that are bridging, you also have the opportunity to mint AO. Again, they're friendly tokens. Fair tokens are friendly tokens. Zero insiders, no pre-sales or closed rounds. It's really an opportunity for anyone to get involved right at the start, and that's something I can really stand behind. Now, one of the things that we've developed is AO DevBot, and the first module that we've created is to create these fair tokens, and they have mimetic properties. So I'm interested in doing the impossible, which is an actual live demo. And ideally, we can get some participation here in the audience. And I think we can just kind of roll into that right now. So what you see right here is our interface for creating these fair tokens. So I'm going to come in here. I'm going to see if the internet will work, and it does, so that's cool. Does anyone have any kind of random word of a token that you think may be funny to create here on the fly? Anyone? Bueller.
Riz.
Huh?
Riz.
Riz token. All right, so let's see what happens here. We're going to make Riz token. One moment. And I barely touched the USB-C, and now we have nothing on screen. That's really what demos are all about. All right. Riz. Make Riz token. All right. Add funny quotes. Okay, so I really input very little details. This is actually connected with Claude in the background, and we also have an integration with OpenAI. Something that's really cool about the AO ecosystem is that AI is actually coming all on chain, right? So there's still more work to be done there, and so you can imagine this entire process completely on chain, which to me is really exciting. You'll see that we got, yo fam, time to create the Rizziest token that's ever graced the blockchain, Riz token. The smoothest, most charismatic token in crypto, pure Riz vibes only. So we're going to let this kind of cook a little bit. Typically, it takes around a minute. And what we're actually doing is not just creating a token. We're actually creating a full interface as well, which ideally will appear on the screen, again, if we have good fortune with the internet. We'll see what we get. I'm going to wait here just for a minute. OK, so now you can see that there's an interface being generated here on the fly. We're going to let this kind of cook a little bit more. And there's an entire embedded bonding curve in this page. We're using a few different templates from the ecosystems, putting all these things together in what I think is a pleasant interface for individuals to explore and have some fun. And it's a great way to be introduced to fair tokens, because all of the tokens that are created on here are 100% community launched. Even the creator doesn't get the token. They have to buy it. So we're really leaning into, hey, this isn't like background, bro deals or whatever. We're actually really putting the community first. So ideally, this can kind of wrap up here. Typically, it takes about a minute or two. In the meantime, I'll pop over to the slides and continue on here. All right, so what we're doing here is we're actually just using the Create a Fair Token module. We intend on creating a bunch of different modules, so you can create mini games, profile makers, website creators, interactive art experiences, and these things actually build out AO contracts as well. Like, this isn't just like, oh yeah, we use Claude and we're making front ends. Like, the whole thing is actually being generated based upon a number of factors that we've been working on actually for a few months now. All right, so we have this site now. We can pop it out and say, hey, like, how does it look? I'm not sure what this artifact is here. This is not part of it. This is like a screen artifact, I guess. All right. You got like some funny little quotes going on. Are you staking because I'm yield farming? Feelings for you? Who knows, right? This is some funny stuff. You can really go wild with these pages. You actually have an embedded bonding curve. It's fully operational when you go to that Fair token launch. So what we can do here is actually generate an actual token image. This is using the HTML content and CSS as well as the prompts to generate a relevant token design. And we're going to see if that actually does it. Full demo mode here. Sweet, we get an error. Awesome. We'll see if we can get through that, and our connection is happy with us. Just a moment here. So as this kind of cooks here, I just think that we have a great opportunity in this ecosystem. AO, the actual token, set the precedent for the ecosystem. We have things like Pi. We have things like Apis and all of these great projects leveraging the notion of fair tokens and really going towards the community. So what you can see here is we got Riz. We got this character here built out. There we go. All right, cool. So we actually have a full site. When we actually deploy this, it actually creates the whole AO contract. It creates the entire bonding curve marketplace, and it deploys to the permaweb. So I'm going to come back to the slides here real quick just to wrap up. Token distribution for this tool is 100%, right? The creator themselves actually had to buy their own token, really standing behind the fair token. It's fair launch season in AO. If you're new to AO, I highly encourage you to check out this model of fair launch tokens. There's an amazing support system that has been created through the permaweb index. I'm not quite sure how many individuals are fully gathering to what extent this can mean. There was an earlier mention, I think, by Sam to the tune of, if I remember correctly, up to potentially like $100,000 a day going into builders, as I interpret it. Obviously, it's very early days and we're learning about that. This stuff is serious. There's an amazing opportunity here. So I just want to continuously repeat that because I want to make sure that individuals are really recognizing what's going on. So we'll be at the booth, the Arweave and AO booth. You'll actually be able to make your entire fair token at the booth. And there's some other fun details. And in the meantime, if you want to sign up, you can grab a spot here. We've had about 50,000 signups thus far, which is pretty amazing. And thank you so much.
Okay, thank you so much, Greg. For our last workshop today, we have Alan once again. Alan, if you flip another coin, you better nail it on the first try, bro. It's all on the wrist. Let's go, let's go. Oh, sweet.
All right, hello again, ETHDenver and the AO Arweave community. Today, oh, we're not even on. Now we're on. Ooh. We're a little glitchy today. What's going on here? Try a different angle up here. All right. Do it. Some minor technical difficulties here. Wouldn't be a good demo without this. Okay, I think we're on. All right, so what I want to do today is walk you guys through a bit of the tooling we have around RANDAO and sort of the process that you might go through in order to generate a random value. So we have a basic TypeScript project here. It's really just a node project, nothing special, no special dependencies yet. And the first thing we're going to want to do is head on over to our documentation where we can get the install for our client library for Randall. Go ahead and install that. Pretty simple. Just a second. We love ETHDenver Wi-Fi. Amazing. And now that we have the actual client here, we'll be able to say, probably have to refresh this. Reload Windows so the node modules work. And if we start typing random client, this should pop up from our client library. And we try to make it as simple as possible to generate a random value. So all of the actual process IDs are stored on chain. We actually query them from the client. So you don't actually have to do quite as much configuration. And we'll go ahead and make our client. And let's see what we can do with our client. We can do client dot create a randomness request. So the way this works with Randall is that we create a request for random for which we give a callback ID where we can later query that callback ID or actually receive the value directly to our process if we're working on chain. And we'll do create request. Oop, I have to await things. Don't forget to await things. That's important. JavaScript. All right. Create random request. And we're going to need a few things here. First thing we're going to need is our provider IDs. And at Randall, we kind of let you choose your own security level depending on your own needs so that your payments can actually scale with the security just as you'd like. So we're going to go ahead and head over to our provider website where we have a bunch of different providers with various amounts staked. And this is really just a marketplace where you can determine where you'd like to get your random from. And today, I'm thinking Fred is probably, he seems like a reasonable person. He's got a good name. Some of these people put weird names. But we're going to go ahead and use Fred as our provider. Providers. And you can use multiple providers for added security. For today, for just demo purposes, we're going to just use one to make it simple. Put that in there. We'll need a few more things. We're only requesting one input. And we need effectively a callback ID. And a callback ID is something you control on the client side so that you know the random that you're getting back is what you requested. My spelling's a bit off today. And this can really be anything you want, so I'm just going to make it some random typings. Place this in here. And we'll await that. What this will do is go ahead and request our random value on chain. And so, good to note, this is running locally on my computer, but all the random values will be generated on chain in a provably fair way. BPM. And that's just a warning about my wallet, which I didn't set environment variables, nothing to worry about. Once we get this on Hyperbeam, it'll be significantly faster because we actually pay to be prioritized, which is a big upgrade we got coming soon with Hyperbeam. And in just a second here, we'll be able to query our randomness by doing something like response equals dot. We have a few different things we can do, but we're going to get our random request via our callback ID. And looks like chain got back. So at this point, the chain is aware that we would like a random value, and our providers here are actually generating that value for us. They're placing their random values, like I was mentioning before, on the chain. You can have up to as many are in here that are active, and they're going to place random values on chain where they can be aggregated, provably fair, and presented back to you. Go ahead and do this, get by our callback ID, and we're going to want to log that out so we can see it. Response. We're going to want to pretty log that, I bet. Stringify. That's 2. That makes sense. And we don't need to request again. We only need to request the randomness. We want to get the value of the randomness that we already requested. And on-chain, this would work a little bit differently, but for demo purposes, a little bit easier here. On-chain, I don't know how to code apparently. That's my bad. What in the world did I do? I forgot a parenthesis. How dare I? So this would work a little bit differently on-chain, where we actually have access to sending messages back and forth between processes, where we would have one process that would request the random from the randomness process, and once the randomness is complete, fully generated on-chain, it will use that callback ID and the process ID that actually requested it and send it right back to it, so it doesn't have to re-request again. Oh, I printed something wrong. What happened here? I didn't. Oh, wait. How foolish of me. And in just a second, we will have our random values, and we'll get to see a bit of the inner workings as well of how we actually generate these random values. So as you can see, we've got a response back, where we're able to see that we had our provider here. I believe this, we have the request ID, and we have the actual, these are some of the inner workings of the cryptography behind it, but we actually have the provider that we requested and what he gave as his random input, as well as the finalized random output, which has been aggregated and finalized on chain. And this is actually what you would use in your math.random function to seed it, which would allow you to have provably fair random. Yeah, so that's really the gist of it. I did want to leave a small opportunity for anyone who had any questions about any of the Randau topics we've talked about today, from providers to running your own node to becoming a developer with using Randau's randomness, or really anything at all. All right. I'll leave a few more seconds of awkward silence, and then I'm going to call it a day. Well, thank you guys. This has been awesome. I'm glad y'all got to see exactly how we would generate a random value on chain, and that it's fairly simple to do. And if you'd like to work with us and use our random values for if you're building a casino lottery, or if you're building an AI on chain, reach out to us and we'll get you set up.
Test, test. Okay, ladies and gentlemen, that was it. Thank you so much for coming to the AO conference. If you're excited about the permaweb, make some noise. It was great seeing everyone. Have a great evening.